And boom, all right. Doesn't look like anybody else is in active chat, which is fine. Please join voice chat if you can. I'm going to post the link right now to the stream and start the drunker boxes. GB. Booyah. And here it goes. And we're live. All right. So, everybody, what are we doing today? Well, this is going to be a drunker boxes, but I'm actually not drinking. Just not in the mood for it right now. But here's what we're going to do. This is going to be a little bit of interactive hardware hacking. So, what I'm aiming to do, what my goal is you guys may have seen these things, these smart plugs. These are available from Amazon. They interface with Alexa and can control a regular AC outlet. They're about $25. Well, they work great. I can say, Alexa, turn on the Christmas lights, and one or more of these can come on and control my Christmas lights. So that's great. What I would like to do is find a cheaper alternative and offer that to others. So I got this at Costco yesterday. I either paid $10 or $20 for it. It wasn't a penny over $20, I guarantee you that. What we've got is 4 remote wireless outlets with a little wireless remote control that runs on a little 2032 coin cell battery. What I want to do is hack these devices to be controllable by Alexa. I've got a few ideas of how that might be possible. I've not even opened the package yet, so I don't know exactly what I'm going to be up against, but that's the fun in this project. And I want to say, I'm doing this project completely for the sake of the community. I have a couple more of these smart plugs floating around, and I don't need them. But for 10 or 20 bucks, this is some entertainment I think you guys will have a good time with. So let's start and talk about general theory. What am I going to do? Well, I'm going to find a way to control these outlets individually by Alexa. So I don't want to necessarily have to turn them all on or all of them off. I want to be able to do it one by one. I'm going to approach it one of two ways. The simple way and the complex way. And there might be advantages and disadvantages to both. We're going to find that out. The simple way, or what I think will be the simple way, rig up a microcontroller to push these buttons for me. Leave all of the rest of the logic there. In theory, I could take an ESP8266 or an ESP32, drive those I/O lines, and be done with it. The more complicated approach, if we find out that it makes sense, is to find out a way to interface with these at an RF level. Let's see what's inside it when we get to this and kind of go from there. So I'm going to start and get this package opened up, and let's see what we're actually dealing with here. Yeah, I'm not kidding. I've never even opened this box, so let's see if I can get this thing cracked open without breaking myself. And we'll get a few of these pulled out. And I can't imagine that there's a whole lot of fancy schmancy stuff going on here. I mean, we know they're not Wi-Fi. They're saying wireless controlled up to 100 feet. They're definitely not going to be Wi-Fi. I'm expecting either some sort of modulated wireless signal or maybe something like Bluetooth, but I would be kind of surprised. But we'll see. We'll get this all opened up and we'll see exactly what we're dealing with here. So, this is like childproof cracking, and this is why I can't get into it. All right, yeah, great. There we go. So there's that. The little user's guide. We'll probably end up glancing at that. And then we've got outlets, and the outlets are numbered. So that says 2, 3, 1, and 4. Let's look and see if these are all in camera view. Excellent. Everything is showing up. Perfect. So let's take a look at the book and see what it says. So, it tells us this is the model CUTNRI 14PK. No idea what that stands for. Instructions. Plug the white indoor receiver, that's one of these, into a grounded 3-wire indoor outlet. Plug the devices to be controlled into the receiver. Turn the devices on. Make sure there's power to the outlet and the receiver is plugged into, and remove the battery from the compartment in the remote and press the on button. So these things, in theory, are all paired up and ready to go. So let's go ahead and pull the plastic out of the remote. And we are going to need to get one of these where you guys can see what's happening. So stand by one while I look around me for a convenient type of power source. And I think I've found one. We will plug into a adjacent power strip I've got here and get ourselves a little bit of desk power. I'm hoping that we'll be able to tell this is working without putting a load on it. I don't want to actually have to like plug a lamp or something into it. I want it to just light up. I think it will. So plug our module in, and yeah, that's good. That's beautiful. So what have we got? Let's just do it locally. Push the button, should turn it on. I don't know if you have to push and hold, or if you just push, or what happens, or if it has to go through a boot up cycle, or what. We'll just kind of play with it here and figure it out. Okay, there we go. I heard a relay click. So on, off. Okay. So locally, looks pretty straightforward. Let's try it with the remote. That one was labeled 1. Oh, wow. I'm not even pushing those buttons. These are like capacitive touch. So on, off, off. Oh, yeah. Maybe I'm too close. Let's get a little farther away from it. There we go. That went off. It's a little fussy. On, off, on, off, on, off, on, off, on, off.
Hello?
Hello, hello.
You have to go in.
Pretty good. I'm just playing around with this little unit. Did a little intro and kind of seeing what we've got here. So this is this 4-pack of prime indoor remote control outlets with wireless transmitter that I picked up at Costco. And I want to figure out how to make these things turn into one of these things. So Amazon's smart plug, they're $25 a piece, and Alexa can turn them on or off. This 4-pack of outlets was either $10 or $20. It definitely wasn't a penny over $20. And I want to figure out a way to Alexa enable all of this. So that's what.
So what do you get? What do you actually get for?
Order the cost.
Yeah. What do you actually get for the price? So
for $20, you get a remote control and 4 of these outlets.
I mean, in the thing that you're replacing, excuse me, with the Alexa, do you get a smart device? Is there an app? Is there like what's everything involved in the thing that you're trying to replace? Yeah, that thing.
Well, you know what? I can demonstrate that by hooking one up and show you exactly what I get out of it. It's pretty simple. So there's an app you need to use to program it, but in short, I take this Amazon smart plug when we plug it in, and I grab my cell phone, which I'm looking around to see if I have with me. I should, because that's where the app lives. Yep, there we go. I'm going to simply go into the app and control, basically provision this device so that the app can operate it. So, let's see here. Where is the Alexa app on my phone? And I can maybe show some of this. I don't think there's anything that I need to hide on here. Let's see, where is the Alexa app? There we go, Amazon Alexa. So we'll open Alexa up. Whatever. So I should be able to go to Devices, Plugs, and it should, here in a moment, discover this plug. So first, second, and third, these are actually plugs that I already have in use in the house, and I've got them tied to a scene called Christmas lights. So what happens, and this is a good demonstration, is I can say, you can see they're all on, I'll simply say, Alexa, turn off the Christmas lights.
Okay.
And within the app, it knows the group of those objects, so I can say, Alexa, turn on the Christmas lights.
Okay.
And she'll control those outlets. It'll take a second. I'm sure the app will refresh and show the new state of those as well. I don't know how quickly or how frequently it polls. La la la. It's like watching a
Do you have to put the plug in sort of like
There we go.
discoverable key exchange mode to
Nope.
add it, or
It
is
just
it just
figures it out. In fact, it's probably there. Let's see if it controls it and just hasn't shown up in the app yet. The last one I did, there was a delay before it showed up in the app. Alexa, turn on the 4th plug.
Sorry, I didn't find a device named 4th plug.
Okay, so it's not provisioned yet. I think that it will. Let's just continue to wait a moment and see what happens. I mean, it's blinking, and that's really all I had to do last time was be in proximity. I'll move some of this other stuff out of the way so we're not going to stare at it. But it should basically just auto-enroll itself. And had you seen the plug that I was actually controlling via voice sitting here, you would have seen it come on and go off. I mean, I could do the same thing with this one. I could say, on or off. It's interesting that it hasn't discovered it yet.
Wait, what did you just do there? I saw the LED change.
There's a manual on-off button. So just like this one has a on-off kind of thing locally, this has one. It's just on the side of it.
Got it.
So same type of thing. I haven't found any other types of functionality yet that it has. Let's see here. Plugs. I'm in devices. I'm in plugs. I don't have anything else in here. I think I just have to wait. Because I think it's discovering it through my phone. Is it doing it through Bluetooth? Let me make sure Bluetooth's turned on my device. I think it's a Bluetooth discovery. I'm pretty sure it's turned on. Yeah.
Are you on? It doesn't need to be like on weird Wi-Fi or anything.
I don't think it did. No, I don't think it did. I think it was all Bluetooth.
So it's probably Bluetooth then.
Let me look at Wi-Fi and see if there are any other weird networks that I'm simply forgetting a step in. Yeah, it's not discovering anything. It's not Wi-Fi, so it's Wi-Fi, but it's not Wi-Fi for this part of the provisioning process. I just have to wait and it'll eventually show up. Alexa, turn on the 4th plug.
Sorry, I didn't find a device named 4th plug.
Interesting. Well, give me just a couple of seconds to troubleshoot that. We'll run a quick little Google-foo at it and say, how to discover Amazon, what do they call it, Amazon plug? Is that the smart plug? Troubleshoot smart home device, connect smart home device to Alexa, set up your Amazon smart plug. Perfect.
To get started, plug in your Amazon smart plug and follow the instructions in the Alexa app to set it up. You can then use your smart plug to control lights, fans, and more with Alexa.
Wow, she answered me back.
And there's not like a discovery mode.
Let's do this.
Panel?
Let's say. Oh wait, 2 devices discovered. View. Well, those are the other ones. So hang on. I'm gonna click Add. Add a device. It's going to be a plug. Maybe this is the part that I forgot that I did. I don't remember doing it, but we'll see.
Well, because otherwise I would really hate it that just plugging it in would sync with someone's app, because how do you know which app it's supposed to sync with?
It definitely did. So there's a barcode here that I'm going to have to scan. I did not do this, the first 3 of them that I did. So this is new. Okay, now let's...
Because that at least lets you know, hey, I want to talk to this device from this.
Well, I guarantee you I did not do this for the other ones. Yeah, now it's connecting and it's programming it. So I don't know why the first 3 didn't have to do that and this one did. Maybe they've just added new security.
Just from a security standpoint, I'd hate if I plugged something in and someone else's phone could capture.
Well, I think what it is it's using NFC or something like that. That's basically, hey, if you're 3 feet from the device and I see it, I'll provision it. I don't think that you stand.
Maybe you weren't close enough. Maybe it was
Maybe it was something like that. But it looks like it's getting there. There we go, plug connected. So now it's there. All right. So 4th plug. So we'll rename this thing. Let's see. I edit it. Settings. Edit name. We'll call it test plug. Done. All right. So Alexa, turn off test plug.
Okay.
Alexa, turn on test plug.
Okay.
So that is exactly the functionality we're looking to replicate with this little guy.
Okay, perfect. That's our baseline.
That's our baseline, and I can control that little guy with this remote by pushing 1 and 0 on and off. So we've got that. So the key is Alexify this. So let's figure it out. Let's tear some shit apart and see what we're dealing with. So somewhere within arm's reach, I have a teeny little screwdriver. I knew that because I just moved it. Now I'm just going to find out where I set it at. And we will open this thing up and see what's inside.
So did you find a tutorial on this, or?
As far as I know, I'm the first person attempting this. I mean, I'm probably not.
I would assume that. Actually, okay, maybe I shouldn't assume, but I would have not been surprised if the Amazon devices have maybe a key or something like that on it.
Well, I happen to know that there's an API that you can leverage that I can use on the ESP8266 to control Alexa. A friend of mine, Brent Volts, has a tutorial online on doing that. His name is VOLTZ. And,
okay, that would definitely make me assume that if you could just grab any device and make that happen, that maybe there isn't a key.
Yeah, so what I'll do is we'll follow some of his tutorial when we get into the software side of things. But right now, I'm just kind of looking at the hardware side of things and figuring out, okay, what do I need to do to make this thing microcontroller controllable, and then we'll layer on the Alexa stuff to it. And it looks like Birdie is out there. He needs a joint voice. Giving us a little bit of additional information on device enrollment, so good stuff.
Yeah, I'm looking at that right now.
Now these seem to my fingers anyway to be capacitive touch because I was not pushing on buttons. So all right, so let's see what we've got here. Ooh, okay, really simple stuff here. Okay.
Can you zoom it into the camera for a second?
I can. Other way. Good thing I'm wearing pants, right? Or that would have been embarrassing just then. Okay. So basically, we've got a PCB.
Oh damn, that actually zooms pretty well.
Oh yeah, it's a 4K camera. It's a legit camera. All right. So nothing there. I mean, literally, I'm touching these. That's literally just capacitive touch through the plastic. So we've got that. We've got a battery. We'll call it holder, although holder is probably the wrong word. And we've got
retainer.
Yeah, retainer, exactly. We've got one IC. We've got a second IC. We've got a crystal and a couple of passives. So let's see if we can figure out what exactly we're dealing with here. Not that it really matters. And then we've got some RF stuff. I happen to see an LC network here. So the antenna is actually built onto the board, and then over here on the left side is kind of a filter. So let's see if we can figure out what we're dealing with from a chip perspective. So the first thing to note is, unless my eyes are playing tricks on me, and I don't think they are, that chip is not labeled with any kind of markings whatsoever. So, mystery chip. And the crystal says 9.84375, so not quite 10 megahertz. I'm going to Google that real quick. 9.84375. And just see what that tells me. 9.84375 megahertz. If I wanted to intercept the RF side of things and drive it, that would be probably a little more difficult. I would have to get a frequency counter, sniff what's actually happening on the RF side of things here, or decode the protocol, reverse engineer the protocol, and do all that jazzy stuff with it. Which would be cool, but I think really, from a simplicity standpoint, just being able to replicate the functionality of a button push in the microcontroller is probably going to be the path of least resistance. So I'm going to zoom out a little bit here. Back to the working space of the desk. So that is definitely a crystal that is quite available. Quite available. So yeah, I don't think doing things on the RF side of things is in the cards, but I think definitely hacking on this from a
Was that,
GPIO
sorry, can you show the
perspective can
faceplate? Was this just the remote?
This is just the remote. Yeah, that's all. You're literally, that is the entire remote.
Okay, so that was just to turn switch on and off, one of the plugs on and off.
Yep, that's
remotely.
It. That's it. That's all it does. Yeah. So if I put the battery in to the retainer properly, let's see if I've got it upside down, right side up, how it goes. Nobody knows. Watch, it's probably dead. I probably killed it. All right, let's see. Here's a battery, and then oh, there we go. Okay. So switch one, on, off. On. Capacitor
nice.
grumpy, right? Let's see, battery retainer. Oh, okay, I see what's going on. Off. It's probably not liking. Yeah, there we go. It's not liking my straight capacitance. Cool. So, rather than doing capacitive touch, it's kind of interesting though, you know? They're doing capacitive touch straight to the IC. So, I could probably, if I knew where to touch, just touch the IC and trigger it. Interesting.
That doesn't seem to be working though.
It did, well, that was a really broad, I mean, it's no different than like laying my whole hand on it, you know, it was a really broad touch, it wasn't targeted. Let's try something a little more targeted. This. Interesting. The capacitance of the knife is somewhat working for, oddly enough, everything but switch one.
So, your T-verse says that ESP32s have touch input.
Well, good. There we go. Well, so it's a little kludgy, but I think we see what's going on now. So he's saying they have touch inputs. So I'm assuming a touch input is nothing more than an input that's not really GPIO, but probably some sort of instrumentation amplifier. I'm guessing. So that'll be interesting. So let's try to map some things out a little bit and kind of see what exactly we're dealing with. So let's get us a little note taking going on here. All right, and a pen. We're going to make a Josh CAD drawing. Boom. Now it's Josh CAD drawing. All right, so we've got.
Can you add a TM on there for me? Thanks.
Add a what?
TM. Chain white.
There you go. Josh CAD TM.
Thank you.
All right. So we've got an IC 1, 2, 3, 4, 5, 6, 7, 8. So we have a 16-pin IC. So here's our IC. Dotty 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 da. Dot. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There. My spacing's close enough to even. All right, so there's our IC. And actually, it's this orientation. So we're going to start to figure out what goes where. I don't necessarily have to completely reverse engineer this whole chip. We just need to know how to kind of emulate button presses. There, shot of water. So, to emulate a button press, this is interesting. Very, very interesting. Let's start mapping out what we've got. We're going to pull our multimeter out and use it. We'll see how this shows up on camera. I actually bet it shows up pretty darn good. So this is a Bryman 235. We're going to use our, and check this out, boom. Ah, there we go. We're going to use our continuity finding mode and map this out a little bit. So, we got a crystal. And that side of it doesn't go to the IC. Nice. My crystal doesn't appear to go to the IC. So what's probably happening is the crystal is probably tied to this smaller IC. And this is the actual RF generation. This is probably just digital logic of some sort. My guess is it's sending modulated data out of this chip into this stuff. And now people are chatting me up.
I was going to say, what was that noise? Like,
That was
hear a little ping.
Jabber popping up. Someone at work saying, "Are you really working right now?" I'm playing, not working. So we'll turn that a little bit there. All right, so good. So this is probably directly interfacing with those other lines. So let's try to figure out what goes where. So we have S1 through S8 on this. We're going to pin number this to pin 1, 16, 8, 9. So we're going to say, where do they go? So pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I can do it in binary and octal too if you'd like. All right.
No, this is good.
So, let's map things out. Let's start with, I don't know, how about ground? So, they've actually labeled VCC on the board, so the VCC is the top, so ground's going to be the bottom. Let's find where ground goes on this IC. Alright. Pin 9 is ground, or wait, no. Pin 1 is ground. Pin 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Alright, so that's the only ground pin, is pin 1. Let's find VCC. Pin 9, no, I'm sorry, pin 16 is VCC. Let's see if we have any other VCC lines. No other VCC lines. Okay, cool. So far, pretty straightforward VCC ground. Looking at the circuit design here, they've probably got some vias. Well, they do. The vias right here for all these leads that we're going to look at going through, and I apologize, I don't have the greatest lighting. I need to get some lighting set up in here. All these vias for all these switches come in underneath the chip, so we can't see where they go. So we're going to have to do a little pinout work to figure out where they go. But we've got switch 1 through 8. So I'm just going to write that down. S1, S2, S3, S4, S5, S6, S7, and S8. Let's find where they go. So switch 1 goes to interesting. I didn't pick anything up there. Let's see what we've got here. So switch 1 is this guy. He goes to that via. So we have continuity to the via. So we know somewhere he's going to this board. Let's see if I just missed it on the first try. Get back here in frame. There we go. Pin 1, 2, 3, 4, 5. So pin 5. Switch 1 is pin 5. Switch 2 pin 7.
So we switch. Excuse me. We switch 1 the on and switch 2 the off.
It does appear that way, yes. I believe those are the on and off for this module number 1. Let's verify that real quick, just to make sure that I'm not crazy, because I think that's what it was. So, battery's in, and I think it's booting. Come on, boot up. I don't think it's making very good contact. Which one's, yeah, that's the positive side, so it should go up.
Yeah.
Alright, we'll get it.
Because usually the bottom is
There you go. No, I think it was just booting. Okay. Alright. Switch 1. Yes, that is correct. 1 and 2 are for that first outlet. Cool. Alright. So we've got that figured out. So those are the 2 we're going to care about for the first outlet, and then we'll just replicate this functionality for the rest of them. Let's go ahead and continue mapping it out just so we know where they go. Switch 3.
Sounds good.
Switch 3 is going to be 9, 10, 11, 13. Yeah, 13. So switch 3 is 13. Switch 4. Then 6. Switch 5. And 14. Switch 6. It's been 10. Switch 7. It's been 15. And switch 8. Is pin 9. Well, that didn't have as nearly of a predictable, organized pattern as I kind of expected it would.
Yeah,
It's just
I
not-
don't know much about pinouts and why people choose certain things yet, so I was going to
it's just
comment
weird.
and decide not to.
It's not real. It's just not real, like, linear. Like, 3, 5, and 7, okay, 13, 14, 15, maybe that made sense, but why wasn't it like 1, 2, and 4? Why is it 1, 4, and 2? You know? So, anyway. So
I guess it depends on what the other pins are actually doing.
Right. So there's ground. 16. There's VCC. Pin. Switch 1's going to be 5, 2, 3, 4, 5.
Wait, so we still don't know what IC this is, right?
Correct. We have no idea. Oh, sorry, switch 1. Doing that wrong. Switch 1. There's no undo in Josh CAD, by the way. TM. Then switch 2 on 7. So switch 1 and 2 work together. Let's see here. Pin 6. We'll switch 4. Nine is switch 8. 10 is switch 6. 13 switch 3, and then 5 and 7. All right, so there we go. So we know what's going on as far as that goes. So what else is on this chip becomes an interesting question. Well, let's zoom in a little bit, get a little tighter, and see if we can figure out what's there and what's going on. Let's see here. Well, we know we've got an output that looks like it's feeding, this trace right here up into that. So that's probably our data outline. So that is pin 1, 2. It looks like pin 3. Let's see if that seems to be correct. Let's get our backlight back on here. So pin 3. Yeah, so pin 3 is our data out. Up there. So pin 3 is data out. And I'll also draw that a little bit on our little sketchy. So what I want to know is, are any of these other pins in use? So what pins didn't we use? We didn't use pin 2 or 4, 8, 11, or 12. So do they go anywhere becomes a question. And it probably, they probably do. They're probably driving these LEDs. So let's try to pick that apart. So one of these LEDs is going to go to ground. So we know one side of that's going to be ground. And it is. So the left side there is ground. The right side is the other line we want to find. Alright, now we didn't find it directly. The reason we didn't find it directly is that resistor right under it, R1, is probably our current limiting resistor. Let's find out. Let's do a little diode check. We were talking about that the other day, weren't we? Where you could light the LED.
Pretty much all I use a multimeter for.
Alright, well, I've never done this with a multimeter, so let's do this. So I'm going to light the LED. Oh, there it is directly. Hey, look, it's one of your badge life backwards through the hole LEDs. So I can tell.
Reverse mounted.
I'm actually not getting it through the current limiting resistor, but I'm picking it up off the other side, so it does tell me that that indeed is the current limiting resistor for the LED. So I'm going to go back to continuity mode, and we're going to find out where that goes. So that probably does hit a pin on the micro. Hey, guess what? It's pin 2. So that is our LED. And actually, how many LEDs are on this thing? Is there a bunch or is there just the one? Looks like there's just the one. Okay. So that's our LED pin. Cool. So now we know our LED pin. So what other pins are on here and why are they there and what are they doing? And I bet they don't do anything. I bet they don't go anywhere. Looking at the board, I can tell you that pins, let's see here. try to do some cool, creative, weird stuff like that. Looking at this board, question is, does that show me enough to know what goes where? They're all happening under the board, so it makes it really hard to reverse engineer it because I can't see them. But that's a cool view. You can actually see all the vias under the chip.
Yeah, I was going to say, are there vias under the chip?
Yep.
The traces on behind?
Yeah,
yep.
The traces are behind, exactly.
So are any of those vias touching pins that we don't have mappings to?
All those vias are the pins. So those vias go nowhere. So there should be 8 vias. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, those vias are our touch pins.
Okay, so
and we've already mapped those out. I don't think that there's likely much of anything else on this. Now I see a component here.
Okay, I have a new question. All those sort of like square. Are there square little traces, like grid traces?
The little grid here?
Yeah.
That is likely the ground plane, and let's find out. Well, you see see this little component here? I am going to fathom guess that little component right there at the end of the tip is a capacitor. Because this first pin, is that 16? Let's see, I got to flip this over, I'm getting too much light on it there. Yep, that's a capacitor. Well, the first one, the one on the right here, C1, this is going to be a bypass cap between power and ground.
Can you shift that a little closer? Okay, you got it.
Yes. So between power and ground, that's going to be a bypass cap just for smoothing the voltage. We have another capacitor here going, it looks like to ground, and then to that last pin, which would be pin 8 that's unused. So that goes to a cap. Let's see if we've got continuity to that cap. Need more light. I just don't have more light. Continuity mode. Pin 9. It does go to the cap. Question is, other end of the cap, boom, goes to that other IC. So pin 9 goes, or 8, I'm sorry, goes to a cap, and then on to another IC. That might be part of this data line. That might be another data line. So what we've got going on up here is an LC network. This is all just, let me get it back in view. This is an LC network. This is all just antenna stuff. In fact, this along the outside to here is probably the antenna. So yeah, I'm really not worried about any of this circuitry because I think this is just support circuitry for this IC. This is antenna stuff. I think we've got it. I think we see what's happening here. So the theory is we need to be able to attack pins 5 and pin 7 for on and off to manipulate that. So now the question becomes, how the hell does capacitive touch work? Let's see here. I'm going to pop a link to somebody and something here. Cool. So how's capacitive touch work? I have no idea how capacitive touch works other than it's, capacitive touch. Gertie, chime in anytime, but I'm going to pull up the Googles and say, how does a capacitive touch work on an IC? So, let's see. And actually, I'm going to change this. I'm going to say, how does a touch pin work? Because all these things are going to want to talk about actual, screen stuff. All right. So Atmel has a one-channel touch sensor IC. So there's a pin called SNS, which is sense. There's a sense pin. And then there's a sense pin called SNSK. So it looks like there's 2 pins for sensing a touch according to that IC. Those 2 pins have a RC network going to a sense electrode and then a cap to ground. So I'm kind of surprised that these pads, that there's not like some sort of counterpose for all that. Back to a question you were asking, though, since I've got some light on it now. You were asking about all these hashes. That is indeed a ground plane, and I believe that they've done it in this grid, presumably in adherence with some sort of design best practice. I don't know if it is suppression for stray capacitance or what it is, but I've seen it before. There is a meaning for it, and I have no idea what the meaning is, but it's definitely intentionally designed that way, and it's all part of a ground plane.
All right. Yeah, I honestly didn't know. I just noticed it was a grid. I didn't know if that's behind the scenes what a normal ground plane looks like. I always imagined it was just like solid
Many
copper.
times, yes. In fact, you know what it might be? It might... Ooh, I see something interesting. Pin 1, 2, 3, 4, 5, 6. Oh, that's going to do a switch. I saw a via here, and I was like, I wonder where that via goes. Pin 1, we said, was ground. And I can see visually that pin 1 is tied to that mesh, so that is just a ground plane. I don't see any of those other pins tied.
I just looked it up. That's called a hatched ground plane.
Yes. What's it say that the purpose for a hatched ground plane is?
Well, I went on like Stack Exchange, so I'm not going to really believe anything I read over here anyways.
Okay. This is interesting. They've got a position for a capacitor to be installed between the antenna and ground, but there's no component there, so that's just curious.
So this person's saying it's easier to solder because of the thermal properties of it, so maybe it doesn't suck away as much heat. Nope, someone's like, that's a lie. Oh man, that's why I hate reading this kind of stuff.
This just got interesting, Batman. Check this out.
What?
I'm counting these vias. Count with me. 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 vias for 8 pads. But this via is not going to a pad. So which pad's missing a via? Switch 4 is missing a via because it's right here. It's the one going through. Is it the one going through right beside the chip that I just mentioned? There. I can't really tell. Oh. It's got to be that one. Yeah, that's the only other via going through there. So it's actually going through and then hitting that pin 6. Alright. So the other via back here is going up to this resistor for the LED pins. Okay, so that's what that other via is for. Alright, so yeah, I don't see anything else going on here. There's another capacitor here to ground. I think that's, again, just part of that LC network. That LC network's probably a low-pass filter, basically, so that any any harmonic frequency above where we're actually transmitting at is suppressed, and it's only letting things below it pass through. Kind of interesting. All right, so really, I think what we need to play with is these two pins, switch 1 and switch 2, and see what we can make happen. So let me bring the camera out. Oh, it's a little tight. Let's see how tight we can go. That's not bad. Not bad for a camera that's 4 feet away.
No, this is actually, you have to send me a link to this camera. That looks really nice.
It's a, let me look at it. This will probably screw up video. Let me turn that. It's a Sony.
I just realized C7 doesn't have a capacitor on it.
We'll look at that here in a second. It's a Sony FDR-AX53. All right, so let's.
What was the last couple digits of that?
AX53. Yeah, there's definitely nothing on that chip, labeling wise. Hell, I should have been doing this. This is easier to see than just using my eyes. That's actually really good. I mean, it's a little wobbly, but that's just because of I'm bumping the desk. But considering what we're looking at what distance we're looking at, and holy crap.
Yeah, and you didn't have to like camera A, camera B, camera A, camera B.
Right. Ooh, there we go. La 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 lights. We can make it shimmer. Shimmer, shimmer, shimmer. So you were saying that there's a capacitor not populated. That's C2, and then there's C7. Yeah, so C7's not populated.
Oh yeah, C2 is gone too.
So
Or not?
see.
No, it's never there.
It's never there. So I'm not too worried about it. I don't know what that's for, but basically what's probably happening. I'm gonna gamble and guess and make some assumptions, but they'll probably be close enough to get us in the ballpark. So the data signal is coming out of the IC here on pin 1, 2, 3. Up to this thing. Ooh, and we can almost read a part number on that. Is that a PT4455? Let's see what that Googles. PT4455. A high performance OOK ASK transmitter for remote keyless entry systems.
You say that in English for me.
It's used in remote control clicky key fobs. It's made by Princeton Electronics. I'll post a link as soon as it loads up here.
Oh, this looks like a really nice camera, but it's a little out of my budget. I need to get an oscilloscope for it.
Gertie Verdi beat me to it. So yeah, that it is a nice camera. It's doing good for what we're using it for. I literally bought it to do this kind of stuff. So.
Oh no, it looks really nice.
It looks even better when you actually have light.
After an oscilloscope.
I haven't got my lights out yet. I mean, that's just me holding the iPhone above the desk, but we'll work that stuff out. All right. So what's happening? Data is coming into that pin 3 on that RF module. And then that last pin 6, the upper left-hand corner at U2, is where your RF's coming out. It's going through L1, C6, that's part of an LC network, and then C8. That's probably a low-pass filter. It's going through L2 and then south, and that's the actual antenna. So when you start getting over here and going, whoosh down, and it actually goes down, over, and up, that's the antenna. So, cool. Very, very cool. And actually, if I click on that link for that Princeton module and open the data sheet, there's probably an example circuit in there. There is. So there's 2 crystals. Let me get to where I can see all this. Too many screens, too little time. All right, 2 crystals. Where? All right. I'm sorry, 1 crystal, 2 caps. So C2 and C4 are likely capacitors tied to that crystal that's used, that X1. I imagine that's what they're calling it on this too. This Y1 module. So these just have to do with this. That resistor is also part of that. Yes, so this is all just part of the oscillator circuit for you two. So none of this has anything to do with touch. Then, yeah, that's an LC network out to an antenna. Data ins pin, they're calling it pin 4. Okay, so 1, 2, 3, 4. So data in pin 4. Pin 1 and 6 are going to be the oscillator. Yes. Pin 2 is ground. Pin 5 is VDD. So this is ground, the ground plane. 3, 4, 5 is VDD. That's data. VDD. No, wait. VDD. VDD. I'm thinking here. Okay, so that's just your VCC. That's your power pin. All right. Yeah, that's exactly how all this works. This is really, really simple. So all of the logic we care about is that unlabeled IC. Excellent.
Which we still don't know what it.
We don't know how it works, but we know what it does. So we know it's capacitively responding. So the question becomes, how do we externally trigger that capacitive response? Oh, I have no idea how to do that. Let's see if we can learn that from Google. So how to extend capacitive switch. Extending touch interaction by indirect touch. Okay, that's an interesting looking video. Let's see here. Convert capacitive touch sensing back to mechanical switches. This guy's talking about it on electronics on Stack Exchange. The capacitive sense controller is measuring capacitance. However, it may not be so obvious what it's measuring capacitance to. There are at least 2 broad systems, capacitance to ambient and mutual capacitance. In the first, your finger makes a larger capacitive connection back to the circuit's own ground. So it's probably detecting a variance between ground, that big ground plane, and the lead. So let's bring the camera back out, get a good working view of things here. That's my guess, anyway. So how do we make a microcontroller trigger a capacitive touch finger?
What's really dumb is I actually bought like a capacitive touch kit on Adafruit and then never did anything with it to learn how it worked.
Here's an interesting. The microcontroller is running at whatever the CR2032 puts out. It's a button cell battery. There's no voltage regulator on this. So CR2032. I think that's a 3-volt lithium battery.
Yeah.
Oh, native 3.3. Excellent. I mean, I could hit it here and we'll find out. So we'll go to voltage. Hey, Batman, this is another use for a multimeter. I'm going to measure a battery. And I'm in AC mode, so let's go.
I'm aware of the concept. I just don't really use it that.
There you go, 3.15 volts. I was being a smartass. All right, so there's an interesting link, Introduction to Capacitive Touch Sensing. So with your finger as a conductor, you've got the virtual ground, blah, blah, blah. Proximity versus contact. We're looking for an increase in capacitance. So how do we increase capacitance? Why couldn't this damn thing just have used regular push-button switches? That would have been too easy.
Do you think that was just a UX decision because it looks fancier?
I doubt it. I
Is
bet
it just cheaper?
I bet it was cheaper. Yeah, I bet it was cheaper because they said, screw it. We've got this plastic case. We can detect capacitance across these buttons. It's one less part we have to buy. All we've got to do is etch pads on the back of a board and have a custom IC. Interesting. All right, so really, we just need to know how to fake it out. So I think what I want to do is I want to break some leads out for test points on this. And once we've done that, we'll be able to do what needs done. Now, the other option, which I haven't completely eliminated, is emulating the RF side of things. So what's happening here? And maybe we need to think about that. Let's talk about that a little bit. So in this circuit, let's make another Josh CAD drawing.
Oh, yes.
Here's a block diagram of what's happening. We have capacitive touch switches.
By the way, aren't TM superscript, not subscript?
I don't know. Let's see. So capacitive touch. That is going to a CT controller. That CT controller happens to be built into this IC that we're using. That CT controller inside that chip, this is our microcontroller, is just like any other microcontroller. So this is probably an analog pin where we're doing some sort of ADC. The microcontroller does its thing and spits out a data stream. That data stream gets fed to this RF module, which then goes through a low-pass filter, probably, and then out to an antenna. I'm making some educated assumptions here, but that's probably what we're dealing with. So the two ways of automating this with a microcontroller is either we emulate this functionality with our own microcontroller, or we emulate this functionality with our own microcontroller. So if we find out that interfacing a micro to these buttons to virtually push them is too difficult, then the other angle is we look at what's coming out of this micro from a data stream perspective, and we mimic it, and we create our own microcontroller that can feed that same data stream into this RF module, and then back out again. That shit's getting deep. That's a rabbit hole. It might be a fun rabbit hole. It's one I have no experience with other than just the theory I just described. But it can be cool. So
I haven't done it before, but I know that's how replay attacks work.
It's exactly what we're talking about. It's a replay. Yeah. So we would basically sniff the data for button 1 on, button 2 off, 3 on, 4 off, 5 on, 6 off, 7 on, 8 off. And we would say, okay, those bit streams look like X. And then we create our own microcontroller to bit bang. We talked about this, to bit bang that same communication protocol. And then we disconnect. We'll completely get rid of their original IC. And we feed our ESP into there. We reuse their RF component. And we're off. Man, you know how much fun this sounds like? I almost don't want to screw with the capacitive side of it now. I almost want to reverse engineer the RF. Wow. This is something. All right, well, let's talk to the community. Let's get some opinions. Gertie Verdi, what do you think? Are we more likely to have success trying to emulate this capacitive touch interface with a micro driving it? Or are we more likely to have success doing replay of an RF protocol. The lazy me wants to go the switch route. The engineering me knows that the RF route's probably going to be more reliable. Drum roll, please. We need a poll.
I don't have an opinion, so
You don't have any opinion on that at all?
no.
All right.
Either.
Come on, Gertie Verdi. We need some opinion here. Tell us what you think. And anybody else that might be in the channel. Nobody else is talking, so.
We have 3 people watching.
Yeah, well, I'm one of them. You're the other, and he's the third.
Does it actually count you?
It probably
Is it
counts me
watching?
because I have a really
Oh,
strong-
it just went down to 2 people.
Oh, did it?
Unless
he left.
now 3.
Oh,
Now there's 3 watching again.
Now it's 3, okay. Well, let's do this. Let's take a detour to the data sheet of that. Let's see here. I'm gonna add the screen capture. Display capture, there we go. For not that screen, how about display 2? Okay. All right, display capture. Let's open that data sheet. So we're going to grab copy, and we're going to pull up the data sheet for this module and see what we've got going on. All right. So the PT4455 is a high-performance transmitter for remote keyless entry systems. It consists of a power amplifier, a one-shot circuit, and a phase-locked loop with internal voltage-controlled oscillator and loop filter. The one-shot circuit control, the phase-locked loop, and the power amplifier have fast startup time and operation. Okay. Applications: keyless entry systems, remote controls, garage doors, etc. So it's perfect for this. So we've got low supply voltage, so 2 to 3. So this is a good 3.3 volt project. PLL-based transmitter with frequency range from 300 to 450 megahertz. That makes sense because this, let me get it back in camera view here. This board, this antenna built onto this board is really small. So what they're probably doing is they're using that oscillator and doing like a clock multiplier on it. So even though it was like 9 megahertz or whatever, so this thing's up in the 300 or 450 megahertz range. So that's cool. That's good for what we're doing. It's a 6-pin SOC 23. So there's our example circuit. That circuit is almost exactly, if not exactly, what's on this board. So what we care about is this data in pin. So we've got data in through some resistors, boom. So this is our, binary data. Let's see what this thing does. It doesn't say anything. We have no information on the data in. Oh, okay. Look at that. 9.844. Isn't that what we said that was? 9.844 megahertz? I think it is. Let me look at that.
I don't know.
9.84375. Okay, cool. So this thing's running at roughly 315 megahertz, give or take. Cool. And it shows us all of these other parts for what's happening. So what it doesn't show us is anything about data. So we know this thing's transmitting data, but we don't know anything about how it's transmitting data. Yeah, he's saying throw a logic analyzer in the data inline. That's exactly where we're going with this. We're going to have to do protocol captures on this thing. Oh my god. Oh boy. This rabbit hole just got deep. Just got deep. There's something else we can do though.
What's that?
Well, we looked at the transmitter, but we haven't looked at the receivers. So, why don't we take a few minutes before we go down this rabbit hole and look at the receiver. Let's see what's inside one of these. So let's zoom in a little bit here. There we go. Let's take one of these apart. I don't know if you were there, Gertiever, when I asked the question, or if you stepped away and came back, but the theory is we have two approaches we can use here. We can either emulate, looking at the block diagram, the capacitive touch functionality and feed it, out and use the existing RF, or emulate like the RF stuff. So either we can emulate this stuff and have a micro do that, or we can get down here into this data stream and have our micro feed into that data stream. I think my engineering high reliability preference is do the data stream stuff. My lazy preference is, man, it'd be nice to just emulate capacitive touch and not have to screw with all that other stuff. But all right, so in this, just kind of looking it over here. Not a whole lot going on in here.
This is the one from
It's one of those four.
From Price Club or Costco.
Costco, yeah. So we got a relay, we got the AC stuff. We've got an antenna up at the top, another network, a receiver, then a micro trigger in that. Yeah, so not a whole lot going on here. So nothing really that's going to clue us in on anything meaningful. So yeah, I think logic analysis is our next step. So, hey Babbitt, what do you know about logic analysis?
Zero. Zilch, no, data not found.
If they make a button pusher with an XY table and some servos, yeah, not fucking happening. We're going to need some volunteers because we're going to cut off their fingers and put them on the servos. So whoever's got 8 fingers lying around, yeah, hook that up to an Arduino and you have the Rube Goldberg. Yeah, exactly. All right, well, I think we're going to do some logic analysis. So, oh boy. So I'm going to need a nice 3.3 volt power supply, or 3 volts power supply anyway. I'm going to need a nice logic analyzer set up. All right. Well, I think that's a good place to push pause. Let me not do that yet because it stops capturing my audio to the stream when I do that. I'm going to go push pause, go collect myself a logic analyzer, bring it in here. We'll start getting it set up. We'll get the software into here. We'll see about getting a power supply onto this and take the next steps to reverse, not really even reverse engineering the electronics. I think we have the electronics kind of mapped out. We're going to learn the protocol this thing is generating. So we'll be
Awesome.
All right, have we lost our audience, or is everybody still here?
I'm still here.
All right. Okay, workspace, yay. So, in this little pouch is our wondrous tools that we're going to use to do this. And I actually have two of them. Here's one that's fake. It's a Chinese knockoff. And here's a real one. Both of these are logic analyzers. Salele, I don't know how you pronounce it, makes this. There's a piece of software that goes with it that we'll be using. And this is a Chinese knockoff that I got from Hacker Boxes. I'm going to use the real one. But what we're going to do is we're going to hook up pins to this logic analyzer. And we're going to evaluate signals and record them and see what they are. And ultimately map them so that we can recreate them using a microcontroller. Holy crap, this just jumped down a ginormous rabbit hole. So, alright, logic analyzer. What's this thing got? Can it supply power? It has a power pin. I don't know if it can supply power. Let's see if this tells me anything. I'm probably going to have to come up with a 3.3 volt supply. Those are the crappy pins. We'll use the good ones. Alright, so let's go to their website and fetch some software. And we don't know what protocol we're looking at here. We don't know if this is a standard protocol or if this is just something they created. So we're going to have to kind of figure that out. So I'm installing Logic, which is the application that is used for this purpose. And once Logic's installed and running, we'll throw it up here on the stream and let you guys see it. And I am going to caveat this whole process with, I have never done this before. I know some of the theory behind it, but this is truly learning and experimentation.
That's how we're going to learn.
That's how we're going to learn. All right. So let's see what we've got here. The app. All right. So I should be able to take the USB cable and hook up my logic analyzer. And we're going to use the real one, not the Chinese knockoff. And hook it up via USB. Okay. And connect to your Mac. All right. So now I'm going to go to OBS. And add a window capture for Logic. Chrome. Can I? What's it called? I don't see it. I'm not seeing it in my list. I don't know why. Hang on. Maybe it's because it's not showing on a screen. Let me do this. Move this to another window. And try to do it. That did it. All right. So this is logic. Logic.
Oh, cool. You have it brought into the stream.
Oh, yeah, absolutely, man. All right, so this is logic. Logic is going to analyze 8 different channels on this analyzer that we can map out what's going on. So we only care about one channel. That's that data input channel. Oh, let's see. How's the pin out on this thing? Ground's this way. So we're going to need a lead for ground because we're going to have to tie to that. Which is black, right? Is it right? No, gray. I can do it the other way. I almost did that backwards. So gray is ground. And then one more lead for channel 1. So I'm just going to use red as channel 2, but it doesn't matter which channel we're using. Cool. And what we're going to do is we're going to tap into that data line. This might be a little tricky, but I think we can do it. The question is, can I do it without having to tack on to the board? And I don't know that I can, but let's see what these clips can grab, and I'll make a judgment call on that. But essentially what's going to happen, and in fact, watch this. We'll take ground. I'm going to take the battery and push it on the board so it'll power up. I'm going to connect ground up. So a little clip. That's not ground, that's VCC. Ground will be on that LED though. So there's ground, and then here's VCC. What you're going to see is that the logic analyzer is able to sample that voltage level. So I'm going to say start. I've got to get in the right window. I'm going to say start. So it didn't like the sample rate I have. So actually, I think I can. I only really care about this channel. Start. Lower the sample rate. Discard the data collected so far. And there's triggers and such. Actually, maybe that's what I'll do. I'll do it as a trigger. So there's nothing there now. We'll just say start. So it ran and it sampled. But yeah, it doesn't like the fact that it's consistently high. So let's do a trigger for a rising edge on channel 2. And we'll say start. And then as soon as I hit VCC with this, it should catch that. In theory.
But never in practice?
But never in practice, I guess. Yeah, it didn't work. All right.
It's just for you.
All right, so are you streaming?
Yeah, I am.
You're not going to believe this story.
Okay. Go for it.
We just went to GameStop.
Yeah.
And we walk in the door at GameStop to exchange a game that was a duplicate. I walk up to the counter, and the chick at the counter looks dead at me and goes, "Hey, sexy, what can I do for you?"
That's funny.
Then, so I walk up to the counter, and she reaches out and goes, reaches out and grabs my beard and says, "Oh, I just got to feel that."
Wow.
See, you could have reciprocated so many ways there.
I'm like, what the fuck? And then, so my wife is in there with me.
Right.
She heard her say, "Hey, sexy," and comes walking up to figure out what the hell was going on.
That's funny.
And the chick was stoned out of her mind. Absolutely stoned. I'm just flabbergasted. Practical IoT and Babbitt.
Are you on push to talk?
No.
Merry Christmas.
Hello.
Merry Christmas.
10.
So that's one of those situations where if the roles were reversed, it'd have been immediate. Everyone would have been like, "No, that is not okay."
No.
100%.
So then, yeah, you're right. But so then the chick comes out from around the counter when we walked off to look at games. She comes around the counter and there's this girl standing there, and she's got this long blonde curly hair. She just walks over, grabs a handful of her hair, kind of flips it up in the air, and walks away. I'm like, what the hell is wrong with this girl? And then Kate, which is my wife, went back to get something. We saw something on the way out the door we wanted. And she went up to pay for it, and the girl comes around and just, without saying anything, just gives her a hug. And we're like, and then she said she smells hot. Like, what the hell?
Nice.
Yeah.
Hey, at least people are trying to be friendly and, happy holidays and, hold
my
beer.
God. Now, like you said, where the roles reversed.
Oh, that person would have been fired and at the police station right now.
Right.
Randomly touching people.
Kate says she's going to call the manager tomorrow.
She touched you again, and I was going to go off.
Do you hear her?
Yes.
Because it's not okay.
No, I 100% agree with you. It's not okay.
I might have hit her, and then she would have been calling the cops on you.
It was so weird.
Alright, so what I've got hooked up here, and it does not appear to be working yet, is I've got this data line attached to what I believe is the data pin off of that IC, going to that RF module, and then ground. And I've got my logic analyzer set up, so I should be able to capture the bit stream. How sure
that you have the channel 2, whatever map?
What? Oh, no, I'm reasonably sure. I'm looking it over. Pin 1. I mean, they're color-coded, but you know what? Maybe that's not right. Let's see. This says black, brown. Let's do this. Let's blow those all out. Because, I mean, I see evidence that makes me think I am. So I've got... So channel 1 is brown.
Connected to something that you can expect a result on?
Well, because this header is one piece, I'm somewhat assuming that they're in order. But I don't know that header came with the... Actually, no, I think I do know that header came with this because the other one is not all in a line. So, yeah, that header definitely came with this. When I hook it up consistently, it's like I can't keep up with the sample rate. So I'm reasonably certain that channel is correct. But, I can capture others. I can get in here and turn them. Do I have to tell it to do them all? There we go. We'll just say start. And then I'll hit it. And then I'll hit stop. See, I didn't appear to capture anything anywhere. At least, at first glance. Now there's a little transition somewhere we saw. Let's see what that is. Actually, it's on the right channel. That might be something. Ooh, that actually looks promising. So what this tells us, we've got a falling edge, and it shows us our exact timing here. We have 13.16 milliseconds. We get that. Interesting. So that would be a 0, 1, 0, 1, 0, 1, 0, 1. That might be serial data. So let's do this. Since we saw something and we see it triggering on a fall, let's set our trigger up for a falling edge. And let's run this again. And let's get rid of these other channels because I don't think it matters. Since I think we're for sure seeing the right channel. this channel. And let's say start. And I'm going to push the on button and the off button. Actually, I'm going to do that again because I want to see the on. So start, on, and cancel. Did I get data is our question. I don't think I had it selected. Let's do that again. Turn off. Go to start. Turn on the button. Hit stop. Hey, what do you think? There is our logic.
Oh, awesome.
Awesome.
We see stuff.
We see something. So let's see if that's all we got. It should be all we got because it doesn't. Oh, wow. There's a whole few things going on in there. Is that all of it? That's all of it. So we got. My eyeballs already see something, I think. Maybe not. I thought I was detecting a pattern that was repeating, but I don't think it is. So I think that might be our actual sample right there. So if nothing else, we've demonstrated how a logic analyzer works and how to collect some data from it. So now we've got to kind of take the next steps. And I think that is the whole capture. Looks like it's taking about, 80 milliseconds? So it's pretty quick little burst.
The wife wants to know how many shots in you are.
I'm drinking water.
Water? You can't get drunk on water.
You haven't drank enough water. Ooh, I just had a perfect idea. Remember I was complaining about light? I've got this little thing right here. It's a little sticky on light. I need to just sticky that under my tripod. I bet that would
It's
really
pretty
nice.
bright.
Yeah, I'm going to try it. See if this gives me what I'm thinking it might give me. That's a little more light. I mean, it's not amazing, but it's a little something.
Your logic analyzer screen's covering most of the video, so I couldn't even tell.
I realized that.
That's fine.
See if it'll let me just move it easily. Yeah, I mean, there's a little something there. It's not perfect, but I mean, you can see the difference of with and without. So there's with. There's without. There's with. So it's something. All right, well, okay. So as we keep going, so we've got our logic analyzer. Try triggering a second plug. So there's that. We also need to capture the off signal. So you're saying exactly the same things that I'm thinking about, and we start getting some comparisons. So what I want to understand is, let's get our arms around what the signals look like, and then we'll see how they vary. But I want to do it a few times to make sure I'm actually capturing the right thing. So let's see what my options are. I don't know if there's like an export or a save, or how you really, how do I save this data now that I have data? Or do I? Or is it just, decoded protocols? And boy, wouldn't that be something if it knew what the hell it was. I'm sure it won't. Async serial.
What logic analyzer are you using?
It's a real Solele.
Who's he? What's it?
A Solele. This little black box right here.
A Sarah?
It's a code Sarah. It's a.
You can't have code Sarah if all you're drinking's water.
There you go, Soleil. It's the company that makes all the hobby level logic analyzers.
The logic analyzer screen.
Sale AE. SALEAE. Salele. Salele. I like Salele, but it sounds like a stripper. I don't know. Salele. Okay. So I don't know if there's a good way to export that data or not. It certainly doesn't look like there is. What's that? Just moving it around? Okay. Well, Hey, there we go. I'll make it a little easier to read. And think that's the whole thing. Ah, okay. I can save it. That's one way I can save data. Okay. Cool. Copy. Yeah, so I'm just playing with it now, trying to see is there a way I can use the tool. Can I decode this as like ASCII data, binary data? I mean, obviously there's binary data there just from the
Did you
pulses.
seek Receiver's suggestion about trying the other switches so we can see if there's a difference?
I do.
Addressing me.
Yep, I did, and I intend to do that. I'm just kind of experimenting a little bit more. Okay, there's a CSV file. I wonder what that looks like. So I can do a save as file. I'm going to save it as a CSV, and I'm going to go look at it real quick. You guys won't be able to see that, but it might clue me in a little bit on what the data contains. Open. Desktop. Hey, nice. It's a 0-byte file, so that's actually not useful at all. Okay. It tells me there's only 13 samples there, so that's kind of cool. Well, I'm going to use that as a quick little pause. Where's my stream? I'm going to pause for a quick bio break, and I'll return, and we'll see what we can come up with on a good way to snap the different one and get these to where we can compare them. So I'll be back. back up. All right, cool. So I did a little bit of looking at the user's guide here a second ago. And let's see if I can convert what I read into how to use this application. So there's supposed to be...
When were you reading this?
Okay, I was sitting on the toilet on my phone reading this. Is that
Thank
what
you
you
for
were...
having him clarify.
Is that what you were looking for?
Important.
I just had to make sure it got recorded.
Alright. Options, which I
Internet
didn't know
wants to
options
know,
was up
I'm
there.
sure.
Oh, you guys can't see it. I'm clicking options and it's... Oh, man. Alright, hang on. There's a whole nother screen that you can't see because the way the window capture is working. Alright, hang on. I'm going to see if I can make that work because I want you to be able to see it. Add another window capture. Nope, can't do that with that dialog open. Oh, yes, I can. Yes, I can. Window capture. Boom. Window logic. We can't do it. All right. We'll do it a different way. Let me bring it over to another. Actually, I don't need to bring it to another screen. I'll just full screen it over here. All right. Cancel. We're going to do a display capture. Window capture will go away. Yes. There we go. Now it's full screen. I think I might have changed resolution, but I think that'll look better when I get that framed in here. All right. There and here. Okay, cool. So.
Got any grapes?
What is that?
That was Tisboyo.
Yeah, but I don't know what it was.
Outcasts. Any waddled away.
Nice. That one. Okay. All right. There's an options button up here that I can click that I didn't know about. Let's see if it shows up for you when I do that. Really? Why are you not seeing that?
Do what?
You're not seeing what I want you to see. Display capture.
No, we can only see the logic analyzer.
Yeah, that doesn't make sense. Or does it? Hang on. Move up.
How are you this drunk on water?
I'm not drunk. I'm just fighting with something. All right. Okay, that's why. It's the other display it's capturing. Okay, hang on. Okay, add a display capture. You're seeing logic, but you're seeing logic for the wrong reason. I'm going to get rid of logic there. And I'm going to add a display capture. And you waddle away. Okay. Right screen. That's middle screen. That's left screen. That's right screen. Alright, this is what I wanted you to see. So, up in the upper right hand corner of logic, I can click options. Yay! Now that I've figured that out. And there is a way to do some saving and exporting and stuff like that. So cool. So channel 2. So let's get to our capture. So here's the capture we made. And there's probably good ways to resize this. I don't know how they work yet. So I'm just kind of feeling my way through it. All right. So I'm thinking, all right, that looks like the whole thing right there. And that's a pretty good representation, actually. So let's go in here. And let's see what all this thing shows us. ASCII and hex. Binary decimal. Let's just say ASCII and hex. And let's do a save capture. And we'll say this was the S1 capture. And since it looks pretty good, I'm going to grab a nice picture of it. And I'll throw that in the window for Discord. Let me find Discord here. Waddle, waddle. All right. Bring that to another screen. we will add that file.
So what are we up to?
Who we got?
We got Super Moo.
The Moo Moo Man. Awesome.
See, you guys been really active lately. I just haven't really been around.
There we go. So I have a little device here that I picked up at Costco for $20. Maybe it was $10. That is a
We can
wireless.
still only see the logic analyzer if you're trying to show
Yeah, I
him
know.
the...
No, I'm not holding anything up. That is a
Just making sure.
but I can. Let me find my mouse. Let's hide that. And hide that. So, I don't know if you're familiar with Amazon's powered outlets. Alexa, turn off plug. I called it the wrong thing.
A few
For
things share the name
test
plug.
plug.
Which one did you want?
Alexa, turn off test plug.
Okay,
Alright, so it turned it off. Alexa, turn on test plug.
okay.
Alright, so those are $25 a piece. I picked up a 4-pack of these things from Costco for either 10 or $20, and it had a little capacitive touch on-off remote control that we've taken apart. And I didn't know it was capacitive touch at the time, but I'm looking at the options to reverse engineer this so that I can Alexa enable these 4 things at less than 25% the cost. So 2 options I'm pursuing. Option 1, figure out a way to ESP32 drive capacitive sensors, which sounds yucky and painful, or the serial data stream that is coming out of the microcontroller to the RF transmitter, intercept it, copy it, and create a way to replay it, and then bit bang it with an ESP and remove their proprietary IC. So basically create a way to replay the data and turn things on and off. Just
Bit banged your mom last night.
messing around. Bit banging what? I thought I heard bit banging your mom was fun, but I may have gotten that wrong or right.
That's what I heard.
All right. Let's see. So anyway, what I've got is I've taken a capture. This is the first real meaningful capture with my logic analyzer of switch 1. So switch 1 is unit 1 on. And now I'm going to try to capture unit 1 off and compare the two and see if I can start understanding anything about this protocol. So, start the capture. There it was. We'll say stop. And let's see what we got. That looks like a lot more data than the last capture.
Yeah.
I mean,
definitely.
a whole lot more data.
You hold it down longer or anything? Or?
Wonderful questions. Don't really know the answer. It's an interesting pulsing that does occur when pushing those switches, but I would expect the data stream to be consistent coming out of it, because the RF transmitter wouldn't be able to deal with weird shit like that.
Do you use the analyzers in Logic?
This is the first time I've ever done anything in Logic, so I'm learning the interface literally right now.
Oh, so nifty feature. You see on the right side of the screen, there's it says annotations, and below that there's analyzers, and then below that there's decoded protocol. You can add analyzers to that, and if it picks up on any of those protocols, it'll tell you what it is in the decoded protocol. It automatically reads those things for you.
So can I tell if it did that? So my original capture, that was my switch 1, which was module 1 on. How can I apply an analyzer to that now that I've captured it? Or do I have to do it while I'm capturing?
No, you can do it now. So you hit plus on the analyzers. And I'm like 3 seconds behind you, so.
Okay.
You hit plus on the analyzers, and you can add any of those protocols, whichever you think it is.
Okay.
So right now, async serial is already set up, and you can edit that.
Okay. So if so channel 2, use Autobot, and so basically just see if it can figure it out.
Yeah.
Okay. Well, I got a lot of things that say framing error, so I'm guessing it probably didn't like me there, right?
Yeah, it might not be async. Go. You can do it to your newest capture because that might be more accurate.
Okay. And I'm just completely guessing because async was the first one there. But, so channel 2, autobod. Yeah, maybe it's not async. Let's do some more analyzers. Let's see what we get. I2C. I would have to be able to. Let me show you more.
All right.
Of what we've already done, because I think it'll help this conversation. Not that. I'm going to show you the Josh CAD drawing, which is a complete hack on the Dave CAD drawings of what we know about this module. So, we have a chip with no name, so some sort of proprietary IC.
The fact that you can get to it is pretty amazing. Usually they're glop top.
Yeah, no, this is actually a real like SOIC style chip. And we've mapped, so there's a total of 8 capacitive switches. There's an LED line. There's data out, so data out's pin 3, which is where I'm connected to right now. VCC ground. I mean, really basic, not shit going on here. But it appears as though it's a one-wire serial interface because I don't see any other serial lines going up to the RF transceiver module. And additionally, we've got a data sheet on the RF module, and it is, let me see if I still have it open. I do. Let's go display capture. So that one. Move it up. That is the application circuit for it. So basically, all I've got is data in right there. So I'm thinking that's async. I mean, it's not like I've got, SDA and SCL pins or MOSI MISO pins and chip select pins or any of that. I've got data in. So that's kind of why I was thinking async serial. I mean, there's no clock signal to it.
Well, there's what's the one that the Atoni 10 uses?
Couldn't tell you.
Atoni 10 uses a special one-wire interface, and it might be the same thing.
I mean, there's Dallas one wire, which I would kind of be surprised if this was, but yeah, I mean that exists.
Yeah, Drunker Box.
But we're not. There's nothing meaningful in this data sheet that talks about that.
Yeah.
Kativer wants to know what frequency was it broadcasting at.
I have not captured it with a frequency counter, but it's somewhere right around 315 megahertz, give or take. I mean, it tells us that it's an OOK ASK modulation, which is probably whatever it's encoding to send to the receivers. That probably has nothing to do with the serial coming into it.
All right, I just want to check in, see how you're doing. You're doing pretty.
Well,
peace out, guys.
Hang around if you want.
No, I'm some StarCraft and friends.
All right, later.
Please don't worry. We see how we rank in the hierarchy.
Right.
You guys got this handled on your own. You got this under control.
Mm-hmm.
We see how we.
All right,
Oh, look, Patrick just showed up.
Yeah, he's been here. Really? 5 minutes?
I just noticed.
What analyzer is that? That's some cool looking software.
It's Logic.
Yes. Logic's free. You can get, if you have hacker boxes, you can get like a really cheap Chinese knockoff.
Yep, which I have sitting here, but I'm actually using a real one.
That's one thing I never complained about out loud. Really, was hacker boxes kept sending like really Chinese like absolute ripoffs. Like not even like the same thing copied and pasted, but like actual rip. And Soleil has actually been posting things for a long time now saying, hey guys, please buy a legitimate Soleil logic analyzer because we're giving you the software for free.
Right.
And we're actually going out of business because you guys aren't buying, you're buying counterfeit shit instead of our shit.
Well, like this thing, let's see if I can focus on it and get it in the screen.
Can I hook up like a bus pirate to that?
Yeah.
Software?
So, like right there, like it says Soleil and it is not Soleil. This is.
Yeah, that's that thing we got that in HackerBox along with the JTAG blast.
Right.
And it's they're obvious knockoffs. Like and HackerBox doesn't give a shit if it's counterfeit or not.
Yeah. Now I'm actually using. Trying to get under this at a weird angle. Back, forward.
Is that what that thing is? I still have it, and I just never knew what the hell it.
Yeah, the logic. See, that's a legitimate one. That's a real Soleil.
Yeah, that's real Soleil. So that's what I'm using.
But that thing there is like $80 fucking.
Yeah. Yes, it is.
All right. Peace out.
Later.
See ya.
Alright. Well, let's see if we can decode any protocols, because now that we figured out how to do that. Alright, so back to the screen. So I'm looking at these other analyzers, so I'm seeing how it works now. I don't know most of these languages. I'm just looking to see if it's like, yeah, I know how that works. So, like the one-wire protocol, but async serial, and it's telling us, errors and whatever. So actually, I mean, some of these kind of look like they could be right. So maybe I just need to turn some of these decodes off. So maybe it's not async, and I just need to say remove me. And then that one, remove me. So we've got one wire. I mean, presence and reset, that's not anything meaningful, so it's not the one-wire protocol. Let's play around with these analyzers some more. SWI. Decode level. Packets. Save. Token wake, so nothing, so that's not it. Canvas. Nope. Error.
She hit me for that comment, by the way.
No, it doesn't look like it's detecting any of these protocols, so it doesn't know what we're looking at. That's okay. Try like one or two more. Yeah, it has no idea. Alright, fine. So we don't know what that is, but we've got some captures. Let's do this. So we've got switch 1 capture. So let's try to replicate that. with another one. So I'm going to pick the channel. I'm going to say start, and I want to push S3. I actually probably need to plug the thing in so I know if it's happening. Let me do that. Which means I'm going to need to rerun that capture because I sent that signal a whole bunch of times. All right. S3. Not happening. Oh, sorry. That one. Okay. Let's run that again. Let that stop. Start. Good. Stop. All right. Son of a bitch. That looks like a lot of repetitive stuff to me. That is repetitive. That is a sequence. Yeah. My eyes can see that. I don't know that we get the same data each time there. Okay, let's do this. I'm going to run start.
What's the time frame that it's capturing onto?
Can you be more specific with your question?
Is there more data because it's looking longer, or what?
Shouldn't be, no. No, what's happening, I'm hitting start, and it's capturing so many samples at a time, and then I'm pushing a button, and then as soon as I push the button, I'm clicking stop. So maybe what I need to do... So I'm just going to watch it without hitting one, waiting for trigger. So I'll try and trigger it. It definitely catches the trigger. And then it'll capture for as long as we run it. Alright, well, I think I know how to start them and stop them reliably now. So let's do this. I'm going to turn them both off. Okay, they're both off. I'm going to click start. I'm going to turn one on. And stop. That's a whole hell of a lot more than we got previously.
They're breeding.
Reset all channels. Oh, that's not what I wanted. Let me hide these channels. Okay, those are hidden. There's that. I'm just going to run start, turn it off, and then hit stop. See, those are all a lot bigger streams than we were seeing before. But you know what? That looks more like a reliable protocol to me. Let's try to decode that. Maybe I had a bad capture at first. Let's see if it knows what that is. There's framing errors, but it's picking up values. It doesn't like it as async, though. Alright, well, interesting to play with. Alright, so we think that this is a sequence, and that it's just retransmitted over and over again. So let's see if I can get over to the beginning.
Are you just hitting the on, like switch one?
That was just switch one, or it was either 1 or 2. It was either on or off. We're gonna have to get more reliable at tracking that, but all right, we'll turn that serial analyzer off because it's garbage. So we've got I need a way to scale this easily. Or do I? Do I need to scale it, or do I just need the data? I mean, I need to know the spacing between things. Is there a way to scale? Bookmarks. You can add a bookmark. Okay. We'll say, let's try one and see what that does. Sneeze. Let's see if we can. Basically where your cursor's at. But yeah, I don't see it there. I think that's just kind of vague. Alright, that's not like bit level bookmarking. Alright, let's see what else we can do in here. Timing marker pair. I think we want that. Measurement. Width and frequency. Annotation, measurement. Oh. Okay.
Good Lord, that was loud.
Sorry?
Everyone says no, you're not.
I'm trying to figure out how do I do this at scale. Let me tell her to quit doing that. Stop texting me, please. I'll be right up. She's like, your son wants tucked into bed. Okay.
Aww.
Well, I will, but, give me like 2 seconds before you text me twice. I drugged him with Benadryl earlier, and he only fell asleep for an hour. I was like, fuck. He needed a nap, and he would just not go down. I'm like, you need your sleep. I need your sleep. Alright, so there's different. Okay, so those are different markers. So if I delete each of those. Good God, there's all kinds of that shit in there. Alright, so the measurements are all up here. A lot of this is just learning to use the tool, it looks like. So annotation, measurement. Let's take a measurement. Let's see if I can measure the whole thing. From here to here. Okay, and then what more do we know about it? There. Rising edges, falling edges. It's pretty cool. We can turn on whatever we want. Compare periods. I mean, a lot of this is going to be about how do I learn to use the software. Yeah, that's what a lot of this is going to be, is how do I learn to use the app. There we go. Okay, well, we're getting a little smarter. So it looks like the width of that transaction is 41.05 milliseconds. So that's kind of useful to know. Let me do a couple more and see if they're the same width. So we'll say start, and we'll say 1 on. Stop. And I'll be right back. I have someone banging on my door.
You're pissing off the cats here.
They don't like that sound.
No, they don't.
Cat looks completely indifferent to everything.
So, I'm back. So I think I know where I want to go with this. I think I want to run a couple more captures of the same signal. Let's see if we're reliably getting a capture, if we've got the same transmission length and all that jazz. And then we'll start looking for differences. Sound like a plan?
Sounds like a plan.
Cool. And I'm eating potato chips. Wavy potato chips.
What? Something about us.
What's that?
I said, what? Something about a squirrel?
Something about spork.
A squirrel.
What? Yeah, I'm confused too. What? No one said anything about a squirrel.
Never mind.
Sorry.
All right.
Have you ever seen Up with the dog?
Oh, with the dog. And he's like, the squirrel.
Yeah, that's my spirit animal. Duh.
All right. So the outlet's in the off state. I'm going to trigger to the on state on switch 1. So the only switch I'm going to be working is 1. So we're going to say, boom, start, 1. That was a perfect capture. So did we get anything? Yes. But look at all that data. That's like a retransmit right there. I mean, I can tell that just by looking at it.
Was that? Does it clear the signal every time, or?
I thought it did.
It seems like we keep getting more and more signals.
I know. Let's find out. I don't know how. I can do that. Now I know it's empty. Okay. Let's do that. Okay, so channel 2. Start. That didn't actually successfully turn it on, so I'm going to say stop. I'll do that again. We're going to start it over. That did. Stop. That's a retrans. Or I mean, that's consistent with what we just saw previously. So it looks like we have 2 transmissions. Ascend and ascend again. You know?
That was a bag of chips.
Yeah, it's a bag of chips. Maybe my assumption is wrong. I'm assuming that the IC, the micro, is smart enough to consistently send a string of data to the RF module for transmission so that it's never dirty across the air. Maybe that's wrong. Maybe it's dirty as fuck across the air, and it's relying on the receiver to sort out the garbage and decide, did I get a signal, did I not get a signal? Because it's not like we're doing, it's not like we've got a connection-oriented protocol here where we can handshake and where we can verify data got there. Maybe it's just send it, send it, send it, send it. Maybe it's just pulsing it over and over depending on how long I'm holding it, and it's up to the receiver to sort it out. Could be. Let's try to prove that. I'm going to turn it off. Now I'm gonna run another capture, but I'm gonna hold the button down longer.
Well, shit! Spoil finally has a Discord avatar.
All right, so I just did it and held it down longer. Let's see what our data looks like. Oh yes, ladies and gentlemen, that did it. All right, so we now know that the micro is sending it in a loop, and then it's up to the receiver to pick one of those events out. That tells us a lot right there. That tells us a hell of a lot. So that's why we're getting different capture lengths. Cool. Well, then let's identify a single transaction here. I'm going to say that it's a start bit. Instructions, wait, instructions, wait, instructions, wait, instructions. So instructions can be sent 4 times per burst, then a delay, then another start bit. So this thing has truly got like several attempts built in. That's kind of cool. Kind of a hack, but it's kind of cool. This is almost like those cheap-ass Chinese modulated RF modules. So unlike something, say, like a Bluetooth signal, where you got really nice, timely protocols and messaging, this is just kind of a brute force approach. Send a bunch of data, make sure it probably is going to get there, and let the receiver figure it out. Interesting. Well, this should be a consistent time cycle then. So let's do a measure. From the beginning, where it opens that, to the last fall. So we're going to look at the period. 0.21 seconds. All right. So I'm going to write that down. So 0.2179 seconds from the start bet to the last bet. Let's measure another one in the same capture. I bet we're going to find that period's the same, or really, really damn close to it.
Josh, you're about to have company for Christmas.
No,
She's
he's
threatening
not.
me with wrapping paper.
Is she? Why's that?
I don't know. It has nothing to do with putting tape in her.
Oh, you mean you're going to get kicked out?
Yeah.
I thought you were pimping your wife out for a second.
I mean, well,
I mean, either way, you get peace and quiet.
Well, I mean, you know.
All right. All right, I measured that entire transactional period. Okay, so we're going to do that same thing again. We're going to measure that entire transaction. From open to complete to last bit. 0.2179 seconds. That's exactly the same. All right. Ladies and gentlemen, we have identified our protocol.
So it's just the same signal over and over again?
It's the same signal over and over again. 4 bursts to attempt to get you the signal. And then the micro loops it and does it again. Start bit, burst, 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 burst. Start bit, burst, 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 burst. So it's a framing approach with 4 data repeats. Okay. Cool. Now,
Forgive me since I missed the beginning of this, but what are the 2 components here that are talking?
identify yourself. I don't have a thing on screen.
The Grand Packard.
Hey, Packard. All right, so what I've got, and I'll switch over to a camera to show you because it's easy to do. Find my mouse. Let's go there. So Amazon sells these things that are Alexa controlled outlets. $25 a piece. So for example, Alexa, turn off the test plug. Alexa,
Okay.
turn on the test plug. I didn't catch her. Alexa, turn on the test plug.
Okay.
All right, so that's $25, one plug. I was at Costco and I found a 4-pack of these things that are similar for, was it either $10 or $20? That their only method of control is this little remote that's on, off for each of the 4.
Mm-hmm.
So what I want to do is find a way to Alexa enable this remote to control these cheap modules. So essentially come up with the same capability for a quarter of the price. And I think I can do it purely by hacking. This is actually the guts of the unit right here. There's one IC that's a microcontroller, one IC that's an RF module, a little bit of support circuitry, and that's it. And then 8 capacitive sensors. So they didn't even put push buttons in it. When I started this project, I thought, oh, this is going to have micro switches in it, and I'll just be able to rig up a terminal and emulate button pushes. Not the case. So now we're looking at, okay, well, if I have really 2 options. I can either find a way to emulate or simulate the pushing of the button from a capacitive perspective. Gee, that sounds hard. Or I can intercept the data stream from the IC to the RF module and find a way to record and replay it. Also sounds hard, but sounds more reliable.
Doesn't sound as hard if you have the right tools.
Well, having the tools and knowing how to use them are 2 different things.
It's true.
I have the tools and I'm learning to use them. So what we've figured out, so switch 1 is what powers the outlet on. And we've successfully captured the transaction that's occurring. Now, we're going to start figuring out how to deal with this data and do cool shit with it. So close. So we're going to go, I'm going to close that one too. Close that one too. Okay. Close that one too. Really?
So have you figured out the difference in the different button pushes?
That's
the difference
next.
in the.
Nope. That's our next step. So now that we've got a way to kind of document what's happening, now we're going to start the comparison process. And I don't know how I'm going to do this. If it's going to be visual, if it's going to be I have to put it into Excel and write down timers and figure all that out. But we're gonna take a stab at it. So this is going to be S1. Now we're going to do a new capture. The next one's going to be an S2. So I'm going to, well, yeah, it'll be an S2. So I'm going to plug Mr. Number 2 in. And control him. All right. And we're going to hit start. And I'm going to go, nope, bad capture, didn't get the data. Do it again. Start.
Do you have any clue what frequency range these things are?
About 315, give or take.
So ISM.
So here is our signaling. And what we measured the first time, we did some timing. So let's do another measurement from the open of the start bit to the close of the last bit, 0.2179. Hey guys, guess what? Our timers match. So that is an S2. And this is where I want to be able to get my freaking menu bar to go away. There we go. All right, so this is an S2. So switch 1, I'm sorry, not switch 2. This is an S3. So they're both on signals. So now the question becomes, how do we compare these things? And I don't know how to do that. Let's see if we can figure that out.
Can you maybe copy and paste them so they're stacked?
Great question. I'm going to try to figure out how to do that in a meaningful way, because I don't know a way to scale them.
Can you export it in a way so you can compare them?
You know, actually,
separately?
Let's see if the... I mean, yeah, those are the kind of questions we need to answer. I do know. Let's see if we can figure that out. So, S1, options... There's a window and a region. What is the difference between a window and a region? Good question. Let's see if I can get the answer to that. Support. User's guide.
I would say the region's probably like using snipping.
That's what I'd love if I can do that. Alright, so saving, loading, and exporting data. So there's save capture. Oh, screenshot region. I bet that's just picture, not data. Okay. So save capture.
By snipping.
So save capture. We're going to call that S1. Replace. And then S3. All right, so they're saved. Let's look at the export data. You know what? Let's do this. That's an S1. Let's try to open S3. See if it'll let us put them side by side. No, it didn't. Fuck. Okay. That would have been cool.
I mean, can you map them to a different, so they're on different channels?
That'd be nice. I have no idea. I think I would have to capture it. I don't even know how to line that up, but let's see what the input output stuff lets us. Let me get rid of some other crap.
could always just do screenshots, compare the screenshot.
That's what I may have to do. I don't really want to do that if I don't have to do that, but we'll see. Alright. I want to do it. Damn it. I want to do it intelligently. Export data.
We're in the wrong place for stuff like that.
Channel 2.
Thank you. I was far away from my computer and didn't run here for
between the specified times. Look at that. CSVs, binary, MATLAB. Yeah, that'd be awesome. Okay. Include column headings, timestamps. Oh, wow. This is going to get fugly. All right, good. Between the specified times. So I need starting and ending times. Okay, well, we can work with that. So on our data, so S1, we measured it twice. So let's look at our, I want start time and end time. Can I get that? Timing marker pair. I don't know how to do that. A1, A2. Maybe. Oh, that. Ooh, okay, okay. A1, A2. Ha ha! And there's start and end times. Okay. So the start time is 1.605 45325, and the end time is 1.82 3385. So if I can do an export data, starting time of 1.605 45325, and the other is 3385. To CSV, include column headings, and fine, export. We'll call this S1. And then we'll do the same thing to here. Timing marker pair. A1 is here. A2 is here. Oh, come on. Really? It doesn't snap to? Alright, so 1.92 8169 125, and then 2.14 604 0625. So let's do export data from 1.92 8169 125 and 2.146040 625. I'll probably find, as I see what this data looks like, that this level of time precision is not critical, but I don't know that yet, so S3 CSV. Alright, 2 CSV files. Let's see what we got in those CSV files. Stand by 1, and we'll find out. S1.csv. Oh, interesting. Okay, okay. And then S1 and S3. I'm going to do a little data combining here, and then I'll bring it over so y'all can see it.
Yeah, because we can't see anything right now.
Yeah, I know that. All right. S1. There's S3. Not horribly awesome, but I think we can make this work. All right. So, let's make this manageable. So what we've got here is the bit stream and the time. I'm not necessarily worried about the time at this point. I just want to see what the bits are doing. So we have a 1 0, 1 0, 1 0, 1 0, 1 0.
I mean, isn't it always going to be alternating, and it's just the time tells you how long it's been on?
That may be a yes. Let's.
That first one is like a start bit.
I think you're right. I think it is. It is always going to be just like that, and the only difference is going to be the time because we only have 2 states. So it can't be that we're using the state to trigger. Well, wait a minute. Let's think about this.
So you can.
We need the time.
I don't know if there's a. You need like a time delta.
Yeah,
thing.
Exactly.
Different.
Because I bet the only difference is probably going to be in one pair. Because it's going to probably wait longer if it's module 3 versus module 1, you know? Okay. We can work with this. Let's go back to Solele. Or back to logic.
Okay, so I know this sounds crazy, but go in and subtract out your first time, your 1.6, whatever, out of each column.
Okay.
And see what your time difference.
Let me pause that for a second. I want to see if Solele can do it for us before I do that manually. But you're right. We're looking for the same result there. I want to see if in my export data I can tell it something like show me differences or something. Let's see. So CSV between the specified times ooh, that's better. Between timing markers. So that we don't have to do the stupid math anymore. Alright. Use timestamps or use sample numbers. One column per every bit, single number, 1 row per change, 1 row per sample. Ooh, don't want that. Time channels. Okay, yeah, we're probably going to have to do it in Excel. Although I want to run this again. Anyway, fuck, I'm not going to worry about this time. The next time I do it, I'll do it. But this whole between timing markers definitely looks like it's going to be easier than me going and looking and writing down the time and doing all that crap. So, alright, let's get out of here then. So what's the best way to do this? So, are you thinking equals that? Oh, I know what you're thinking. Hang on. I'm going to insert a column here.
I'd say the best way to do it is going to be subtract out your time and then subtract that exact same time out of each of the other.
Yeah, exactly. Because we're just looking for a difference. In theory, they should be the same. So we're going to look for where they deviate.
Well, what you want to do, go back up to the top. You did that wrong. You want to.
Okay.
You want to make that D2 equal 0. So it needs to be the value of E2. Let me think about that.
Well, I'm not trying to compare 1 to 2 directly. I'm trying to figure out what is the time between events 2 and 3 and 4 and 5. So I want to compare it to itself.
I understand that. So do E2 minus the value of E2, and then okay. So let me think about that. do
So it's
equals
really-
E2
It's really
minus.
really
Hang
2
on,
and
work
3.
with. Shut up. Do in D2 do equals E2 minus money money 2, and then drag that all the.
Well, that's going to be for column E. I was doing it for column. I was wanting to do it for this first.
I love it that you called it money rather than the
Money.
sign.
All right, so walk me through that again. So forget E because I want to do it. I want to do it on A, but
Equals E2.
you keep seeing A2. I want to do A for. I want to do the first. I don't want to do E.
Echo 2.
I don't want to do Echo. Echo's my second one. Echo's
Oh,
switch 3. I want to do switch 1.
I see what you're saying.
Okay.
So minus money A, money 2.
So what's that mean?
That does a relative, or not a relative, a specific cell instead of a relative cell. So now if you copy and paste that all the way down, it'll subtract the value of A2 all.
So that's going to be the duration between
Of each
like
state,
2
yes.
and 3. Yeah, okay, we're looking
Grab
for the same thing.
Grab
Okay.
the corner. Yep, you got it.
Yeah. Got
So
it.
if you actually look at the formulas now inside Excel, you'll see that the A,
Right. No,
because of the dollar signs, keep it there.
yeah, I didn't know you could do that kind of a formula. So okay, cool. So I'm gonna take that, and actually it probably makes sense if I do this. I'm gonna go fucker. Insert, and then just nuke this one, delete, and then actually I'm gonna do this one. So this one is going to be the time window S1 time window S3. And the only reason I'm doing that is so that they can be next to each other, so it's an easier comparison. So then this formula here goes here, but this time it turns to E $E $2, is that right?
Yep.
Yeah, and then we'll drag that down, and we're going to look for the differences between them. Because in theory, they should be dead on, except one, I think we're going to see runs longer or shorter. All right, cool. And they might deviate a little bit. Let's see what we got. I'm surprised those are different.
They're not different by much, though. That might be within the margin.
Yeah, because most of them look pretty. 5, 7, 5.
I wonder
yeah.
if this is where we should round something. Let's do
How
this.
many significant bits we want here?
Yeah, I think we can do that. Format cells. Number 2. Let's see. 3742. 3742 5 3742. Let's go to that and see if that gets us close.
I love that there's this side conversation going about a puck nuts.
Yeah.
13, 8, 9, 11, 13. I want to go smaller. I want to go smaller.
That's what she said.
That's what she never said.
Really? Let's see. So we're at 7. Let's go to 6 decimal places. Let's see what it looks like. 373 to 374. 891. I want to go to 5 decimal places. I just want to. There we go. Okay, 37, 13, 8, 9, 19, 58, 2, 3.
There's going to have to be more difference than one 10,000 or one whatever place that is.
Let's take it another point away. This is kind of fun because we can kind of see it getting closer and closer as we do it.
And then what's the value? Is your timestamp? Like at what point do you know that you're showing not enough significant bits?
We just need to see a big jump, and I just want to get it to where it's rounding enough to see a big jump, and I think we might be there right now. So 4, 130.
Yeah, I think that got. There's a difference on 13.
But not by much.
Yeah, not much in 116.
Yeah, everything I've seen is only off by 1.
Yeah,
we'll do this, and then we'll see. Maybe we'll see one that's 10 off.
let's see if I was doing that, I'd start messing with conditional formatting and all that.
Yeah,
to make it automatic.
Not for 200 res. I'm not that good at Excel. Plus, I think we're going to see the difference be bigger than that. Like, that one is somewhat significant.
Yeah, I agree.
Whoops.
Yeah.
That one's significant. Oh, fucker. Back up. All right. So, question, would those, if I'd lost a decimal point, would those still be off?
Yeah, because you'd have 0.050 and 0.0.
Well, let's try this. Let's format cells and drop one more decimal point, and then scroll it down and see if they still match. Might speed this process up. Yes. No. See, like that one. No, I don't think that's enough resolution. I think we need that other decimal point. Okay. Well, we'll leave it there then. So that one and that one are off. That one's off.
Man, I'd really like to see just a huge jump,
I know, like
2 or 3 10.
But it doesn't necessarily have to be that huge. If it's a recognizable pattern, it might be enough.
So why a huge jump? What is this switch 1 and switch 3?
Yes.
For comparing?
Yep.
So you're trying to find out where the address?
We're trying to find addresses, yeah.
Right.
So it might not be a big jump. It might be like that's a big jump.
It might just be 1 bit.
It might just be 1 bit, yeah. In fact, it's likely just 1 bit.
That's a pretty significant one, then.
Yeah. All right. We're halfway through. Now I'm starting to want to do fucking formulas. It's the difference between two cells.
I'm so lazy that I would have immediately just
All right.
figured out how to do if statements and then
Excel,
copy paste.
yeah.
Oh, I'd have went straight to conditional format.
Yep.
That's what I'm looking at now.
Without having the computer in front of me, I couldn't tell you how.
Well, we've got a couple examples on here we can play with. All right, let's get to one where it's on the same page. Okay, so if new rule. That doesn't look right. Conditional format.
You probably want to look for gradient, but I don't know how to do the formatting to do the whole. Especially because, believe it or not, Mac Excel is actually different from.
I think I see how to do this. Oh, damn. It's not. No, that's going to take too long. It's not just greater than. It's different. Because, like, this one's smaller than. Let's see.
Right.
You could deviate both. Well, could you? I was going to say you could deviate both directions.
Well, you could do it.
Because, like, this one's less than this one, but this one's greater than this one. Yeah, so it could deviate different directions. All right, I'm just going to keep doing what I'm doing. By hand, then. All right. Because I'm halfway there. Okay. Yellow, yellow. Yellow. Orange. Yellow.
Never in my wildest dreams I thought I'd be on the weekend looking up how to do Excel conditionals because I want to.
Because you want to, right? Never did I think I'd be reverse engineering a fucking serial protocol. That currently we're going to call the Babbitt protocol because it doesn't have any other name. And you were the first person to join the stream, right? Let's see here. So now you have a bus and a protocol.
Is that for the? Does that work in conditional form?
Does the Babbitt protocol
So
work
if
in conditional formatting? What?
No. So there's a conditional that you can add the roundingness and compare two values, and then instead of saying okay, you could just do empty string, and instead of error, you could do difference.
Yeah.
And then instead of and so basically it's just a ternary. So if they're equal, it does nothing.
Exactly.
Then,
If they differ by more than X, light it up. That's kind of what we want.
Oh well, this doesn't actually do the more than X, but you could do.
Because that would help us do. It's probably like noise reduction.
If you subtracted it, the rounded values, and then did absolute value greater than something, that would work, wouldn't it?
I think once we zoom out on this, we're going to see what we're looking for. Let's see, because we'll be able to get to timestamps and we'll be able to know where to scroll to in the capture. Because I think visually seeing this on the screen is going to clue us in. We're going to see where the shift happens. Because I think most of these yellows that I'm highlighting are just deviations in accuracy, just drift. Whereas some of the orange ones I think were more than drift. Because like if you look at this one, 0.1877 to 78, we're only at 1, and then down here we're still only at 1. So it's like over this whole period, the drift has been pretty low. Drift, 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 drift. That's a big one. That's a big one. They're the same. All right, so let's zoom out and see what we're dealing with here. So 2, 3, 2. So in this whole capture, there are only 1, 2, 3, 4, 5, 6, 7, 8 transitions that have a significant difference. Okay. So that's good to know. Between the two. Let's find out how big of a difference. So equals that minus that. And let's look for the big ones. 9/10. Ooh, and actually, you know what? Let's do that up here. This is what we were talking about, actually.
Yeah, you want to subtract them.
Yeah, we want to subtract them, and then we can conditional format on greater than.
Did you do the column? I didn't actually see with the formula.
I basically said take the time window for one minus the time window for the other.
That doesn't look right here.
Well, look, you'll
poke
see
at it.
There, I'm on it.
See, there's no dollar sign in there, so I was comparing
D2 minus C2, and the next one's comparing D3 minus C3.
Yeah, and that's what you want.
Yeah, that's what I want. I think that's what I want, I don't think I have enough decimal places. But I'm not looking for a huge difference. So the yellows, it didn't even catch it. It's like, yeah, it's still 0. But when I get down here to an orange one, it's like, oh, that thing's big. So it knows, hey, that's way off. So that's what I'm looking for, is stuff like that. So those two. There's one there. There's one there. That was an erroneously orange one.
So I don't expect more than 3 or 4 bits being done.
And you know what I'm finding here? They're all different by about the same amount.
Well, because so you got four little blips in each block, right? Every time you press the button. So I'm thinking that it's repeating itself.
1, 2, yeah, 3. There's the other one. 4. Yep, that's exactly what it. Oh wait, 0.09. That 59. Yeah, that's it. Yep, we agree. That's us seeing the repeats. All right, excellent. So we're getting there. So it looks to me like it's towards the end of the data stream, probably. And it is right about at that point, at 1.655. So let's jump to logic and see if we can go to that marker. So it's at the tail end. wonder if Logic can open twice. Let me try that. That'd be cool. No, I can't. All right.
I'm surprised there's not a way you can get both of them on the screen at the same time in like a split screen or.
I know. That's what I'm really looking for. I just want to compare. Exporting data. I'm going to do this. I'm going to do a compare. Search for the word compare. Document. Nothing. Well, the word compare isn't there. Let me do a Google search. Compare to captures and say LEA Logic. How do I compare signals from different captures? Currently, the software does not contain specific features for comparing data between captures. Currently, the best way to compare signals from 2 or more captures is as follows. Save each capture to a file. Open each capture in a new instance of the Logic software. Resize them so they're all the same width, but I can't open instances of the software. All right. For some analysis, it may be easier to export the raw data to a separate CSV file and compare the data sets using Excel. It literally, yeah, that's what we did. All right, well, that's fine. I think I can do this. So in 1, so we're going to be in S1. I want to go to this flag here, 1.655, that timer. So let me see if I can find a way to do that.
Did you see what Therm just said?
Yeah, I just did.
No, I can't see Discord. Over here.
Hang on, she hasn't seen it.
Okay, we'll wait for the reaction. Oh, she's typing.
I don't get it.
She's awful quiet and
She hates there because you keep sending snow over to Tispoyo's house.
I don't get it. I don't
She's
think I
just
have
putting all the weather blame on Therm.
I don't
And
know
so
who
he
this
said,
person is. Who
I
looks
sent
like
you
is
a box of
Ruined Air?
snow.
Yeah, I don't even know who
she
that
says,
is.
I might have to kill you now. I apologize to your wife.
Is she new? I don't know that name.
Who?
Ruined Air.
That's my wife.
Oh, okay. I'm like, I don't know who that is. That's why the joke's not making sense. I'm like, what are you talking about? Okay, back to Logic. Okay, so I need to go to a timestamp. So we know what the timestamp is. So how do we do that? How do we go to a timestamp? 1 second. 600 milliseconds. How do I? 6, 7, 8. Timing marker pair. B1. No, that's not what I want. We need the cow on here.
He's too busy playing StarCraft to hang out with us tonight.
Let's see here.
Mm.
Go to specific time and silly Logic. Navigating your data.
Was it StarCraft you was playing, or was it Counter-Strike?
He said StarCraft, I think. Whatever that is.
I'm pretty sure
maybe.
it's StarCraft.
Maybe he just said that he used to play Counter-Strike with those.
So this software is free, but I'm not really that impressed. I think it kind of sucks. It's just like, it's got basic features, but it's got no, like, wow, cool.
Yeah, but also just maybe you don't know how to use it too. Might have some
True.
cool shit. You just don't know.
Well, let's do this then. I'm going to go to my timing markers, and I'm going to delete them, because we kind of know what they are now. Delete the measurement. So we're going to measure it from the start of the bit and see if we can figure that out. So A1, A2, delete that one too. All right, so timing marker's gone. So from the beginning, I'm going to add an annotation. Timing marker pair. Nope, not that. I'm going to add a measurement. And our measurement is going to be from here.
It says
milliseconds.
oh.
So we're going to look for 1.65.
It says analog devices software.
Yeah, that was good. T first said it's better.
It's got to be in one of these blips.
He's
here.
typing more. Share your wisdom with us.
Do
Oh, I know what it's doing. Okay.
You're kind of getting cut off there to spoil. I don't know if you mean to do that.
Milliseconds. 13 milliseconds.
I thought about buying one of those. The one podcast I listened to, they have a discount.
The analog discovery.
Yeah.
Yeah,
it's
man,
like $100 off.
Your whatchamacallit, what the hell, like
Ham radio workbench.
Your push to talk release delay is.
Oh, it's because I'm on
low.
my phone.
Got it.
So these, I'm having trouble with this. S1. These seconds don't match. Are those seconds times seconds? So I'm looking for 1.655 seconds. So where the hell's that at?
How much does the analog discovery go for?
Oh, I just grabbed a random one of these. Okay.
So Ham Radio Workbench has a discount code for the analog discovery. It's like 100.
65538. That's right.
100 what?
It's like $100 off of the analog discovery 2 or something like that. That they have. Did you listen to the newest episode of that podcast?
Oh no, I haven't yet.
All right.
It's actually pretty good. It's got some pretty good basic information.
Oh sweet, I'll have to check it out. That's the ham radio benchmark, right?
Yeah.
All right, people. I think I found it. All right.
Ooh, share your knowledge.
So here is our capture. So I happened to look at the last sequence. So we've got from the end 1, 2, 3, 4, 5, 6, 7. So we have 7 transitions. So it's the end of the 8th transition from the end. Let's look at that in both of them and see how they differ. So that's the high state. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have a long one, short. So a long high and 2 shorts, a short low and a short high. So a long high, a short low, and a short high. Then we have a long low, short high. Fuck, it's hard to track this. 1, 2, 3, 4, 5, 6, 7. Okay. Long low, short high, long low, short high, long low, long high. Long low, short high, long low. I think it's right in here. Okay, let me do this. So this is our S1. I think we can compare them visually this way. We'll grab that that block. And then our S3. Probably not an exact alignment there, but we'll see if we can make it work. And then that one. I think it's right here in the tail end. So now we're gonna go to our screenshots. That one and that one. Okay, open that one. And that one. So there's one. Here's the other. We'll probably have to scale. All right, that's not horrible. That's actually not horrible at all.
Oh man, I'm still way too lazy to do a comparison on that though.
You're still what?
I'm still way too lazy to really look at that hard enough to figure out where the differences are.
Oh yeah, it's right in here. You can kind of see it. All right, so it's right here at the tail end. So we've got, you know, hold a piece of paper in front of the screen and slide it over, and you'll see the differences. So that's the same.
I think you got a handle on it. I'll let you do that. Cheers.
All right, I'm doing it right now.
I definitely see the difference.
Oh yeah.
Oh, I guess I could see stuff at the end. It's super different too.
Yeah.
Bingo. Yeah, it's happening right in here. Ah, fuck. All right. Move it over here. Of course we can't do that, all right? Well, fine. We'll make this easier to look at. Go like that. And then we'll open that one. That's that one. All right. It's just the tail end. Everything else is the same. It's literally only different from here to here. This little section. You guys see my mouse moving okay? I don't know if it's capturing that.
Yes, so we can.
All right, cool. So, we don't necessarily know what a timing value is, but we know how to observe it and we know how to replicate it. So since we know where it's happening, all we have to do is build code in Arduino to create this same series of transitions with these same timestamps. Wow. That's pretty sweet. And then by creating this code, that's bit banging. So we'll basically feed it into the module. You know, we can disable the IC that they're using, feed it into the module, and it should trigger. Cool. And we've essentially got all of our delay values in here as well. In this spreadsheet that tell us how long to wait. So it'll be in delay 0.0139, delay 0.0152, delay 0.0156, and do. So we just build a protocol now. All right. Well, with that, I'm going to step away for a bio break, put the stream on pause, and we'll be right back.
Oh my God, we gotta code this thing tonight too. Shit.
Oh fuck! Coding this is easy now. I just grabbed some cheese wrapped prosciutto wrapped in cheese from the fridge. See if this is any good.
Fancy.
Yeah. I'm always really conscious when I'm streaming about what people can hear. So I think I've said it before.
Really?
But I'm sitting
Wait,
here.
you say that as you're eating chips.
I'm not worried about that.
Right?
It's like when I'm sitting here holding a conversation and I just let the largest fart. It's like, did they hear that? And I'm like, I bet they did.
Oh my God, I was walking through the store yesterday and I let one rip and there were people everywhere.
Turning. It's like,
This
you're
is
just
a great
like,
conversation.
it's like, I know
Yeah.
they had to hear that. Like, how could they not?
Your mic does tend to drop off on occasion when you stop talking, so I don't know that I've ever heard that, but
Who was it the other week on one of the drunker boxes? Somebody's like, who's fapping? Oh. I think we know how to do this.
Because it alternates between high and low.
All we're
You're
doing
just gonna say
is on and off. It's just 3-volt logic.
what editor do you like using? Oh, you use Arduino, right?
Mm-hmm.
We can make this faster. Do you have Sublime or Atom or anything like that?
Oh, sure. Yeah.
See if I can remember. I can't actually remember shortcut keys when I'm on my laptop. It's just their muscle memory on my desktop keyboard. But what you could do is grab the difference column that you're interested in. Actually, let me think about that for a second.
It's very easy to automate the writing of this code. Yes, I'm following where your brain's going. Yes, we can automate the writing of the code. I can throw a simple script together that says for each line in this for each line in this file, create an entry with a command and fill in the value, something like that. Because after all, there are a bunch. But the first thing I'm going to look at is breaking this sequence up. I'm going to run another export. I'm going to break the sequence up into one stream because I've got the whole thing in there. So I'm going to grab just one occurrence. So S1 is where we're going to go. And go ahead and make this thing big.
Yeah, you just want one of them and then you can repeat it 4 times.
You got it. Yeah, we only want one of them.
And then do you even think we're going to need to repeat it 4 times?
We'll do it just to mimic what they're doing.
But yeah, let's try it once to see what happens.
Yeah,
and then
I'm all for it.
Wrap it in a function and call it 4 times.
I wonder if it has some kind of debounce on the receiver that if it says, "Oh, don't do it again until it stops sending it,"
It doesn't even matter because the state is on. It's a different signal for off. So who cares if you say turn me on 30 times?
That's
I didn't realize that.
Yeah.
So you could send it 100 times and it's still going to stay on.
Right. You got it. Okay. Cool. Well, let's capture.
So then, have you figured out which is on and which is off? Then is S1 on, S2 off?
Yep.
Perfect.
So we're gonna set some markers here. So A1 right there, and then
phone's at 4%.
And actually, there will be two sequences. We'll have to monkey with this. Actually, I bet we won't. I bet the last bit. Let me measure something real quick.
Oh no, my laptop's dying with my cat sitting in my lap, and I'm trying to decide if it's worth it.
So 13.52 milliseconds. 13.52 between the falling edge of the start bit and the first bit of data. 13.52. Let's see if that's the same as the distance between the repeat. Like maybe the stop bit is the start bit.
Yeah, it looks like it might be
Oh,
close.
it's real damn close, yeah. Cool. So I'm guessing that it is the same. So real life.
What's the time there? I can't.
0.003 milliseconds, or no, 0.03 milliseconds of variance between one and the other. That's okay.
So
We'll do it like this. We'll say code the start bit. That'll be a function. And then we will do all the data. And then we'll just do repeat data. So it'll be send start bit, then it'll be send command, then it'll be send command.
Just make sure if you're going to do that, you put, well, yeah, I don't know. You have to make sure to put that.
We'll put that delay in there.
Right.
No big deal. Okay. But we're going to start with just the one sequence. So there's our A. We're going to put our A2 right here.
A.
And then we're just going to export the A's. The A's have it. All right.
What are you talking about?
The A's have it. Samples between A1 and A2A. All right, we're going to, excuse me, call this.
YouTuber's like shaking his head so hard right now at us.
Who is?
Beaver.
You know, if Bald Engineer were watching, I bet he'd be proud of us for banging our way through this. All right. Let's see. We're going to call that S1 single. And then we're going to go to Succel and open it. S1 single. Open. And there's our data. So we're looking at 52 events. That's not that bad. Okay, cool. So, god damn it. If she don't quit texting me. She's like, you're down there playing. And I'm like, no, I'm working. No, you're playing. No, I'm working. This is work. All right, let's see here. So really, it's that in the sequence. So we're going to go. I just heard a really loud noise like someone fell. I'll be back. Make sure.
all survive, or do you have a
I
Coke
think-
fountain?
I
A
think they
momentary Coke
survived.
fountain.
All right. So let's do some math here. So
I guess the question is, did the 16-year-old survive?
Yeah, she's fine. All right, $A. Is that what you're wanting?
A.
Your formula here.
I don't know. I can't see it. It's too small.
That's what she said.
I was waiting for it. I knew as soon as that came out of my mouth, somebody was going to say it. I expected it to be Batman.
So did I. She was a little slow on the uptake.
We'll cut her some slack. She's not.
Yeah, I have a really bad cold right now, guys. Give me a break.
All right. So let's see here. So our formula is actually
Wait, are you already? Sorry, go back to the other. Are you already storing the differences
no.
in the other
That's
sheet?
that's what I'm wanting to calculate. I'm wanting. This is a whole new sample.
Oh, got it.
I just want to do it again. So equals.
You did something weird there. Yeah, I think that actually grabbed it from a different file.
I know.
So
it was
it's
trying. It was trying to.
2 minus $A $2.
Okay. That's what I was looking for. All right.
Yeah, the dollar signs. It won't let it shift it when you move it around. I don't know the actual terminology
Okay.
for that, but
All right. There we go. So, what we going to do here?
so what is that in time? Is that are those microseconds?
Those are fractions of a second. So I guess that depends on how we calculate this. So we're going to want to make it into milliseconds, right? There's 1,000 milliseconds in a second. Is that correct? That's a yes/no question.
I was trying to get back to my push to talk button. Yes.
Okay, so if there's some milliseconds. So we want to convert this into milliseconds. So if this is... So we're going to want another... Where's my mouse? There it is. So that's going
And I think milliseconds is probably the finest resolution you can get out of an Arduino, isn't it?
It is, I believe. So we're going to say equals... Fark. There we go. So
do you ever use Fark?
no, what is that?
It's like Reddit
Oh, okay.
before Reddit, before Dig.
So is it like there's gonna be like some divide by 60 times 1,000 or something in here? Is it gonna be
Yeah, I'm not capable of mathing right now. Someone else figure this out.
no problem? Let's see. Wait a minute.
Okay,
Let's
so what
just
are you
divide by
trying to do?
1,000 actually, because those are already in fractions. So equals. I'm gonna start down here. So this is an actual value of that divided by.
I mean, you're already looking at 0.01 whatever seconds, so 0.0125 is, in milliseconds.
Yeah, like that. So 37. Is that right? I can check that. Hang on. Convert seconds to milliseconds. Seconds to milliseconds. Okay, so that. Boom. Multiply the time value by 1,000. So that. Yeah, so I had that right. Okay, so that's milliseconds. So 0.37 milliseconds. All right.
That might be a little tough to pull off with an Arduino.
Yeah.
Because at that point, you're talking about nanoseconds, and I don't know if the clock on it is fast enough.
Oh, well, I'm sure it's fast enough. That's just a start bit, so.
Oh, okay.
The rest of those look pretty good. So if we're
I mean, hell, you may be able to completely skip the start bit, and my phone is at 1% if I disagree.
I think he
We
just
salute
went.
you. So
Yeah.
thanks for stopping by.
There he goes. All right, so if we're gonna run, yeah, let's see, shortest.
Oh, I see the rest of them now. They're saying 13 milliseconds. Yeah, you're.
Yeah. So actually, in this, if we just do some rounding. And we go to that. That's probably going to be good enough. No, that's not right, guys. Our formula's wrong here. That's not calculating the delta. we were trying to compare before. I just want to go equals. I just want the time between. So this is going to be equals that minus that. Cancel. Hang on. I dragged in more.
And that's where you should
That's
have your
better.
money.
That's better. Okay. So we're looking at 0.37 milliseconds. 13 milliseconds. 1.3. Alright, so let's look at the Arduino delay value. Shortest delay minimum. Ooh, Arduino has a microseconds delay. Okay, hang on. Is this right? Let's see. There is a delay microseconds. Okay, well, let's find out how to convert this to microseconds then. Because that might be easier to get right. Seconds to microseconds. So if it's that many seconds, 20 plus 6. So actually it's going to be, we just changed the formula.
Okay, I heard Arduino has what, and then my phone died.
We're going to go to microseconds instead of milliseconds. I think it's going to be easier math.
Okay, will the Arduino handle microsecond?
Yep, there's a delay microseconds command.
There we go, that worked.
They're integers, so those need to be whole numbers even. So this is partly going to be an experiment because we're going to have to go to that. Now we should still be within the margin of error, I would think. Okay, so now that we have that, we're going to make a new spreadsheet here that'll be what I export from. I'm going to grab the bit.
Did you like kick your wife off her computer and then you're just still logged in as her?
No, I stole her phone.
Yeah, that doesn't sound better.
Do what?
So that doesn't sound better.
Why?
You stole her phone?
Well, we're not at home, and my phone died, so yeah, I stole hers until she's done doing.
All right, so here's what we're going to do. We'll write code to do this. We're going to set the bit to 1 and delay that many microseconds. Set the bit to that and delay that many microseconds. Cool. Why the fuck? Oh, my format cells was off. Okay, hang
So do the microseconds have to be in whole number?
Yeah, they're integers. That's fine. There we go. So that is our import CSV. Cool. So that should be one whole sequence. And you can even see that based on that delay. This is your start bit and then data. So we're going to go save as.
Oh, that's why that one's 13.
Yeah.
13,000. I was wondering why it was so.
We'll save it as a CSV. This will be our S1 sequence.csv. All right, so we have a CSV file. Now we've got to automate writing our. Actually, you know what?
That should be simple enough to do in a function.
That's what I was thinking. I'm like, fuck, I can do that in Excel.
I mean, you should be able to do that in a function. Just say, turn it on and delay for whatever the value is in this array. After the delay, step to the next function. If the value is on, turn it off. Wait. I mean, that should almost be like a 3 or 4 line function.
Fuck, I can do that in one equals here in Excel. So let's see. Delay okay, so I'm gonna do this equals that delay microseconds. Boom. Equals B1.
Oh, I was thinking doing it, putting it all in an array in Arduino, and then just doing it basically a for loop, to walk.
You could.
Yeah.
You could. I'm just going to do it here because it'll just be a copy paste. And if not, I'll have fucking experimented with it here. But you're right. You can do either way.
There you go. That's what it's all.
Delay microseconds is value B1 and then that. Okay. It might. Oh. And B1. There we go. So we're going to do this. Copy.
Oh, I see what you're doing. So you're just going to copy the whole thing into the function and do.
It's just like, fuck, well, there's my delays. Boom.
Right, and then just between them, you put your right on.
That didn't work. Yeah, exactly. Copy. Face special values. That ain't working. All right, hang on.
It's because it's not doing the round. Excel still sees the whole number, all the way out to the bazillionth position. You gotta do the.
But if
So
I
you
do
can
copy,
you can no in your function. I'm
listening. I'm a little delayed here. You're looking at streaming. Remember that.
In your in your column there, you can do rounding inside your function. Say take.
The round.
It should just do round comma 0.
Yeah, that's where we're at. All right, hang on. Round B1. There we go. Mucho better.
There you go.
That brings us all of our delay commands.
Nice.
So we've written all that, and now we're going to say, let's see here. Our highs and lows. Is that easier to do in Arduino, or is that easier to do?
See, now you have to keep track of whether it was on or off.
Actually, I don't. I just need to send it digital write high or digital write low. I don't need to care if it's already high.
You don't care what the previous status was because you're going to change it.
Right.
Or you're going to set it for what you want it to be anyways.
Right, but he still needs to write that part.
Right.
So I like the array idea better.
And we
toggle.
Well, I mean, we might still have value in that then. So for each, because I want to write two commands. I could do this in like Python or Perl, but you're right. We could do this in Arduino somewhere. But I should also be able to fucking do this in Excel.
I mean, you could just on the first line say inside your column D.
Yeah.
Write the state to be A.
Okay.
The value of A.
Right.
Semicolon.
Can I do multiple lines in that function or in that formula?
It might not actually break it up, but we could use Sublime or Atom or any of those things to do a global select and put a new line there.
Yeah.
Actually, you might even just be able to say print new line.
You're right. We could just do a print new line.
Well, I think can't you put multiple commands on one line in Arduino just by putting a semicolon at the?
Yeah, but you don't want to
do that. Let's do this.
Well, he's already making it ugly by doing it this way. So what's a little more?
Nah, I think we're close. How about if? Let's do
let's
an
not,
if.
Let's not transgress too bad.
All right. Equals if.
We got standards here.
Oh, okay.
Equals 1.
You do realize 1 equals high and 0 equals low, right? So you can do not right 1.
Yep, that's what I'm going to do here. So if A is equal to 1, comma, value of true. So how about boom? Close. So if A1 is 1, value of true.
You got to do that as a concatenate.
Okay, how do I do that?
Type concatenate.
Where?
I think it's concat, right?
Well, you can actually. Let me look. I'm trying to look at that. I don't think you need the brackets in there. I think that's your problem. Take the square bracket.
Yeah. Nice. Cool. Now we're gonna go over here.
Thought you were putting them together. Which in that case you would use a concatenate. But you should be able to just paste that in and then do like Babbitt said and use the editor to.
Yeah, that's where I'm going. Right
so
now. Right.
You don't have semicolons in there though, do you?
Nope.
This would be a lot. Put a semicolon at the end.
Okay. We can do that. That's easy. Where do you want it at? Well, at the end of both statements, actually. So it's going to be like that. And then that. And then you want it after the delays too?
Yeah, so he's putting it on both statements.
Cool. We're all so fucking lazy. It's amazing. Because this is exactly the kind of approach I'd take doing this at work. It's like, fuck it.
Oh no, I do this shit all the time where it's like it really wasn't worth the effort.
Right.
I mean to write a whole. So watch this. Select a semicolon. Highlight it.
Okay, hold on. Yeah.
And then do I think it's Control Command G.
Okay.
So it did it. You might need to hit the arrow, left arrow,
There you go. Enter.
and then hit enter.
Well, that gets us damn close.
Did you accidentally delete the semicolons because you still had it selected?
How about I do this? There we go. And now, how do I just slam all that shit to the left?
No, hold on. We need to fix this.
Arduino has an auto format.
Yeah. Check this.
I didn't know that.
Yeah, I didn't either.
I didn't either until I just saw so many egregious mistakes.
Yeah, they weren't egregious. There were only a couple.
But there's a lot of really cool little things in Sublime that you can do like that I like doing.
Let's see. We'll call it S1. Boom. Boom.
See, inside the loop, right? Hold on. Scroll up. It's hard for me to look at this code.
It's inside. I created a function.
Okay, got it.
How do I do that?
It's under
Auto
tools, I
format.
believe.
There we go. Auto format. Look at that. Hell yeah.
Oop, oop.
Cool. What do you think? I
I
like
think
it.
a function would have been way better, but
What the fuck did I just? I just wrote a function. What are you talking about?
of an array that you fed into a function that would toggle. That's just me. This is fine.
Oh, you don't like the fact that I broke it into individual commands. You want to just look in an array and then do the thing.
Mm-hmm.
Okay.
But this works.
She wants to do it the right way.
Well, I'm
I
gonna
mean,
make some changes here now too. So watch what I'm gonna do here. We're gonna call this send s.
Of course, then again, by doing it this way, it does kind of remove some of the possibility of something else slowing down, causing the loop or whatever, causing something weird. Or
actually, that's still possible that we're setting the delays on what we want,
Right.
but there's still like a natural delay inside Arduino.
right.
All right.
I haven't really programmed Arduino all that much, so I don't really know what that number would be, but it would not surprise me.
Yeah, I don't either, but it could be a matter of subtract 1 microsecond off of each one, or the receiver might have enough tolerance in it.
Let's find out.
Okay.
But that command control command G would also be a good way of saying, hey, go to everything that I'm doing a delay on and subtract that by 1.
Oh, no kidding.
Without having to actually go through every single line.
Is that an Arduino or Sublime?
That's just a Sublime trick.
That's pretty cool.
And Atom, that works in Atom too, and I imagine VS Code.
My wife says she hates you because you have a mechanical key.
Oh, that sounds so cool.
I have one too. She can hear it from downstairs when she's upstairs. So I get it all the time. Especially if we're really having a conversation in chat and I'm just typing away. Yeah, yeah.
Do it like that, I guess. I'll know what the pin is soon enough. Verify. Yay! It likes me, kind of. All right, we're gonna call this. Fuck, I don't know. Serial mess. All right. So we have some code here. So basically what you're witnessing is bit banging.
Alright, sweet.
I would put like a delay 10 seconds at the end of it, at the very end of it, if you're putting that in your main loop, just to keep it from continuously
going to
doing
measure it. I'm going to go measure what the delay is, have it repeat so many times, and then, I'll put a big, giant fucking delay or something.
Right.
Or we trigger it with a button or something. We'll do something along those lines. But yeah, you're right. Why is it taking so long to save? It's like saving.
Of course, I mean, you could tell it, put your turn on code in there and then delay 5 seconds, and then your turn off code, and then delay 5 seconds, and just let that loop, and it'll
we don't have any of those other codes yet. All we've got is this one. This is pretty damn good progress. I mean, we've beat the shit out of this tonight in one session.
Yep.
It's only lasted like 6 hours.
I know, right?
4 hours, but yeah.
Yeah. Yeah.
That's okay. You're still the one last night with Pyre was 6 hours.
Yeah.
Oh my God! Now, did I see correctly that Sarah was in there?
Yeah.
Yes. Sarah from Code Sarah
to
officially joined.
I'm gonna have to go back and listen to.
She's pretty cool. And then IoT's like, so you dating? She's like, oh, you're classy, not responsive. And he's like, so you dating?
I believe I used the phrase bumping uglies at one point.
Well, yes. And then, there's IoT's way of saying that, actually.
Wow.
Yep.
It was mostly just coercing a blush out, but it was funny. And so we should also probably do on setup.
You should,
I really want to go back.
Oh, what was that?
I was gonna say I really want to go back and watch Bald Engineers because I was asleep when he did his the other night. I'm hoping he left it up.
Oh, yeah, I don't know. I didn't do the link. Did you see the end result that Pirate though posted today? The little animation.
His roulette wheel, yeah.
Yeah.
I
had him go on voice and let me know because there's a buzzer on there. Oh, it sounds so cool. It kind of almost sounds like a dot matrix printer going really fast.
Oh, that's all. Cool.
So, was it that he forgot to put his bodge wire in?
Yeah, I believe so because he's like, oh shit. And then an hour later he's like, okay, here's working.
I
think that's what I saw in the chat was he said after you said put the bodge wire, I think that he said in the chat that's
so
like we were troubleshooting that for a good almost 2 hours.
That's funny because last night when I went to mobile and I was heading up to bed, I was gonna lay there and listen to you. He started troubleshooting it, and I said, "Hey, make sure you put that bodge wire in." And my wife reached over and hit me with a pillow and said, "Shut that shit off!" And so I could have saved you guys 2 hours of work.
We did not hear that for sure. Otherwise, that would have saved us a whole lot of time.
It was on push to talk, so
that is tough.
I know. And I was like, "Okay, fine, I'll turn it off."
I mean, to be fair, come on, dude.
Hey, when you did one a couple nights ago when I was watching the video on my laptop, I set my laptop. I told you I was going to bed. I set my laptop on the nightstand and just let it play. And was sitting there listening to you guys talk. And I started falling asleep. She goes, "Are you going to turn that off?" And I shut.
It's when you say no.
Come on, you guys. People are trying to sleep.
Some headphones in, man.
Yeah, I'm sure. Put some headphones in.
So I think I know what I'm going to do before I make an order of PCBs.
What are you going to do?
There's so many design them anyways. But I was looking through that post you linked, Beth.
All the 555 projects?
Yeah. One of them is make the old. Remember those guns? They go boop boop boop. Like
the pew pew,
those sounds?
little laser guns things.
Yeah, you can do that with 555s.
Oh, yes.
You just like a speaker up to it and generate the signal.
Oh my god, that's amazing!
Wow.
I'm gonna have to go find that one in that list. I ordered some 555s. What else do you need out of that?
I'm pretty sure it's just other like it's the 555 is incredibly diverse. It's just the resistors, capacitors. I don't even know if I saw inductors in any of those diagrams.
So you guys want to hear something funny? Where I was first introduced to a 555.
Sure.
Okay.
I used to work for the TSA. For 8 years, I worked security screening at the airport. And the very first time I ever heard of a 555 was when they were talking about building improvised devices, and that they would use the 555 timer as a detonator.
Oh.
What? Wow.
Right? Because I remember thinking then, what the hell what is he talking about? What is that? And the guy doing the training, but he couldn't explain to me how the time.
So this is why TSA gets excited anytime they see a bunch of loose ICs around. I get.
I guess.
Right. My coworker that would go to DEF CON, I'd usually dump a bunch of shit in his car because I fly out there. He just left, so I don't know what to do this year and how much crap I really want to bring on the airplane.
UPS.
It's especially expensive during DEF CON. They like up the prices because so many people do it. At Caesars.
That's
it's
surprising.
Stupid. Yeah. Or maybe Caesars just has a ridiculous. It just costs too much.
Caesars is always expensive, even when the convention isn't there. Like this year, it's across the street. It's still like 50% more for the same.
Yeah.
Probably because they know people are going to destroy the room.
They probably are going to
maybe
destroy the room. All right, cool. Next step. So we've got code written that should bit bang and turn shit on. We've got the module. I think the next step is to fucking take this IC off the module, run a couple of jumper wires so that we can hook an ESP up to this thing or an Arduino of some sort and send some fucking signals. So I think we need a hot plate. We need to do a little desolder. Actually, you know what? There's a couple different ways I can do that. Hot plate could work. That's probably the easiest.
Are you just going to connect up to the existing, or are you going to try and remove the chip off of the?
I'm gonna lift the chip. Well, should I lift the chip yet?
I wouldn't, because you don't have all your signals.
Right, I shouldn't lift that chip yet. That chip's not gonna do anything. I'm just gonna solder.
I can't pronounce his name. Like he just said, I would just piggyback a jumper.
Yeah, that's what I'm gonna do. I'm just gonna piggyback a jumper because we don't know if we're gonna need that yet. All right, so I mean, I can always put it back on. You know, I can always put it back on, unless I lose it. I'm just gonna pull it. Fuck it. I'll be right back. I'm getting a hot plate.
Oh Lord! Right, all this work, and he's gonna just and have to go buy another one.
And he's like, "Look, I only had to buy the kit 3 times to save $0, but it worked."
Return it as faulty.
Yeah, I mean, it's the journey, right?
It is.
Like, time also being money. This is, even if it works this first time, I don't know if it's really cheaper.
Well, if you only have to do it once and you get it working, and even if it takes 6 hours to do it, it is part of the journey of.
Okay, so I'm compromising. I'm not going to use a hot plate. I'll use my real rework station.
You're not going to use a what?
I won't use a hot plate.
You use a rework tool or something?
All right, so when you have shitty weather like you do in Ohio,
Yeah.
and you salt the steps, don't come home barefoot with salt on.
Wait, what? What happened?
We had ice and whatnot, I don't know, last week, and there's still salt on the steps. And I didn't put my shoes on before I came home, and I just walked across the.
Ooh. I mean, how cold is it right now, too?
When did we have ice?
I don't know, like 2 weeks ago, and there's still salt out there, and it's about 35 degrees.
I must have not left the house because I don't
Didn't
even remember
put
that.
your shoes on? I don't know.
All right, Batman. I'm going to be
So-
better about this. Here we go. Are you familiar with a rework station like this?
I actually am.
Sweet.
I don't have one, but I have used one before.
Sweet. So I've got an infrared preheater under here that we'll use to bring the board up to temp. I'm going to do.
That's fancy.
I'm going to go.
Is that a hot plate or a reflow air tool or both?
But well, it's a hot air rework station with a air gun and a regular nozzle, all in one unit.
But it warms the PCB up before you even put the rework on it.
Right. So I can use the air or not use the air. We'll just see how it plays. So let me go get some tweezers.
Nice.
That's what she said.
Cool.
Have you found the markings for pin 1 so you know which one is pin 1 when you have to put it back?
Oh, yeah, we should probably do that because I think he just picked an orientation because there wasn't any markings on it, but maybe he saw something I didn't because he's there in real life.
All right.
So, have you marked the pin orientation so that you know which pin goes where when you have to put that thing back?
I'll take a photo of it before I do it.
But he means, is there a physical marking you can put on it so you know the right orientation?
Yeah,
or is there already a notch you can look at?
Chip's got a dot on it.
All right, there you go. That was a good question, though.
Yes, it was a good question.
Enhance. Yeah, it just looks like a black icy to me. I can't see it.
You will.
Maybe my screen darkness is too. Hold on, let me change that.
You will when I put some light on it. Upper left-hand corner.
All right, yeah, I can see it.
Enhance.
Right? That is. Ah, there we go.
Enhance.
So, okay. So what we're going to do, I need to find power cord. Find a power cord.
Oh, where'd all the light go? It was real bright a second ago.
That was his cell phone.
He has my iPhone.
Okay.
You should. IKEA used to sell these little like clamp lights. I wonder if that would work here. They're like.
You know, I just have one of those. Looks like the Pixar lamp that I bought from Walmart for like $10 on.
Yeah, I got like a really bright. It's really a magnifying. It's a lamp, but it's also a magnifying glass, and it's like the brightest LEDs ever.
I've got one of those here. I just don't have it here in view of everything. So let me move a few things around here. All right. Let me go get that because I think you're going to want that to see a little better. So let me do that. Ugh.
Yeah, I wouldn't complain at all if it was brighter. So you're gonna take the IC off, but just U1. Yeah, that's exactly the light I was thinking of, Gertie.
I'm not just
You also
going to
have-
take the chip off. I'm also going to solder on a test lead. And or
Anyways, real quick, those lamps, a lot of people also have like you can unscrew the base and then people do little 3D printed things, so you can just mount them all over whatever the hell you want. I know someone who he modified his 3D printer to have 2 of those on the side of it.
Oh, that's pretty awesome. So you're taking the chip off and then you're putting the Arduino in the chips?
I'm just going to attach a little test lead to that data line.
Okay.
All right. Can you guys see okay? Got a little light there now.
Yeah, this is great.
Yeah.
All right, cool. So,
I guess it's okay.
It's all right.
It's okie dokie, babbies. All right. Let's see here.
I do like your setup, though, that you can zoom in and out with just a single camera.
All right, so we're going to go IR preheat plate. And we'll preheat the plate, which is on. I'm going to take it up to 250 Celsius. So the plate is preheating. And in fact, I'm going to zoom out so you can kind of see the whole thing happening. There you go. So we're slowly bringing the board up to temp. So we're at 40C right now.
Oh, it's not too bad. I came out to the garage check on the hot tub, and it said 88 degrees because it had shut off.
Yeah.
But I just turned it back on, and now it says 99. So
cool. We're at 62C now. We're at 80C. I'm seeing a little smoke.
So what's the preferred, like is 250 a good temperature to put a board preheat on?
Just depends what you're trying to do. I don't really know. I'm just kind of watching it, and if the solder melts, I'll know that it's ready to pull the chip off.
I'm just guessing that's a temperature you've used and not fried a board, so.
That's the last temp that was set.
Oh, well, it sounds good enough.
Yeah.
So is this so that you don't have to use the rework tool as much because it's already close to the temperature?
Yep, that's exactly what you're doing. You're trying to get it up to working temp so that you can just hit it with air, tip it just right over the edge, grab your part, and be done.
all right. So I'm going to put the phones on the charger, see if I can get the laptop running, and hopefully the battery's not dead because I'm not sure what.
We're at 209. We're 240. All right, we're at 250. I'm going to go ahead and bring preheat up a little higher. I'm going to bring it up to 300. we're at 300C. We're bringing it up to 330. I'm just kind of watching it. I might just, depending where I hit the temp,
aren't you
it might
just
reflow.
basically using this as a hot plate at this point?
Kinda, yeah. I'm kind of using it as a hot plate, but without direct surface contact. It's all
not
air.
even kinda.
No,
like
it's all
actually.
air. It's air. So rather than having physical contact with the heat, it's just air.
Okay, fair enough. I didn't actually realize that it was air coming out.
It's not even like blowing air. It's just air radiating.
Interesting.
What would that be? Convection instead of conduction? Or no, I think it should be radiation rather than conduction.
Oh yeah, you got much more light now. Now I can really see it.
Yeah, so that's 330. Let's see if I'm not quite up to melt temp yet. Let's take it higher. All right, it's set to go to 4. I would think we'd see this thing reflow here at some point.
Unless it's a lead freeze daughter, then it might take 400.
Well, I'm going all the way to 400 right now. Everybody's staring at the solder on that. I'm staring at the crystal. I don't know what you guys are staring at.
I was just staring at you one.
We're at 369.
Nice. Oh, I see your subscriber count went up, IoT.
It did. Am I 70 now?
72.
All right.
Somehow there are 6 people watching this.
Really? Okay, cool. So we're at 400C. Let's see if anything's
Well,
loose.
you got to figure I'm probably 3 of them.
Okay, because you're but you disconnected on the phone, right? Oh, it's still really on there. What's the temperature it's at?
400. We'll go higher.
Awesome.
Nope, I can't go higher. That's my maximum preheat. Okay. Well, we're gonna let it sit there for a second because it just may, just because my temperature sensor's at 400 doesn't mean the board's hit 400.
True.
We'll just kind of see what's happening. Yeah, no, stuff hasn't.
The Wi-Fi is so shitty in my bedroom because of where the route or the access point is sitting that the dog jumped up and got between me and got between the computer and the access point, and I lost my connection.
All right, we're gonna add some air. Come on, air. Come on, iron. There we go. 450.
Is there actually a capacitor on C2? It looks like it's open.
It's not there.
No,
yet.
C2 and C7 are not there.
I wonder why.
Ah, here we go. All right, let's do this.
Oop.
You won't be able to see the action, probably.
Oh, that's cool though. It has like a little target stand thing.
Oh, yeah.
So you can futz with the things with both hands without having to hold that too. The one couple of times I tried using a rework. One is when I was trying to get the NeoPixel on the little breakout board.
Yeah.
I couldn't solder and hold it and do the rework, and I just actually blew the NeoPixel away. I know what I was doing.
It's done. It's off.
And it's off.
See how easy that was?
Ah, where'd it go?
It's right there to the right.
I can see it.
Nobody sneeze.
Right.
So that's cooling.
Really?
And I'm going
Sneezing
to
all day.
turn the preheat plate off. Actually, you know what? I'm going to leave it. I'll tack onto that by hand. So, yeah, I'm just going to let the preheat come down. Let that board cool. So, yeah, that worked out nice. Let me spin this the other way. There we go.
That did work pretty good.
Yep.
Because all you did was put the heat over the top of it, plus on the bottom, and then just picked it up.
Just picked it up, yeah. Yeah, that's why there's fairly low risk of jacking it up too badly. I mean, it's literally... Yeah. I mean, that's clean.
Ooh, pretty.
Are those hacker box tweezers?
No.
There was a pair of tweezers came in hacker boxes that were like super, super sharp, and I love.
I've got the hacker box tweezers, but those are not them. I've got a whole tweezer pack.
So speaking of boxes, I emailed Adafruit again, and they said they're going to look into it, and I haven't heard anything back.
I mean, you already got 2 of them sent to you at this point, right?
Well, the second one was just a label. It doesn't show any movement. The first one showed the label and in transit to UPS, but it never showed up.
Oh, okay. So they probably meant to send it to you, but only got the label.
Right.
Well, here's a cool thing, too. Now we can see those vias and what's happening under the chip. Because we were wondering about it.
Yeah, I was thinking the same thing.
For some reason, my video likes to degrade down to like 144p, and I don't know why.
Yeah, mine did that in the middle of the stream. I was like, did his webcam
Done it to me
that
twice now in this stream. I wonder if it's because I have the video playing on one side of the screen, and then I put a focus on another screen, so it thinks I'm not there.
It stayed since I've said it, and I've been focused elsewhere.
Oh, yeah, I wonder why. Did it to me twice now.
I'm going to run and get some stuff for my soldering iron here, and then we're going to tack a lead on there for testing. While the iron's heating up here. So who actually thought I was going to, like, set the board on fire?
Say it one more time.
Show of hands. I said, who actually thought I was going to set the board on fire? Show of hands.
I mean, anything's possible when you're involved.
All that work, and it's fucking broken now. All right, let's see. I have a jumper. I have a jumper. All right, we're going to hit that data pin. Let's see. I want one strip. It's actually somewhat tricky for me to do this hand soldering without being under a magnifier with my eyes. We'll see. I guess I have a magnifier, just not my scope, a microscope. No, I don't like that. Get a little more temp on my iron. This is where a good engineer would have put some test points somewhere.
You mean on a cheap mass manufactured little board like that?
Right.
I'm sure on version 0.1 there might have been test points.
That sucks. Oh, nice. Autofocus is almost handling that through the magnifier even. It's like, I'm trying, man. That's not horrible.
It's working pretty good.
Yeah, I mean, I've seen a lot of, not a lot, but I've definitely tried following some people on YouTube, and anytime they go close, it's like 10 minutes of, oh, is it going to focus? Is it going to focus? Is it going to focus?
All right.
What camera is that?
Babin's got the info on that camera.
It was, I forgot already, but hold on, I have it in my history.
Is that the like $800 camera?
Yeah.
Yeah, I call that.
So nice, though.
It is nice.
I posted a link.
Oddly enough, this looks damn near better than the fucking microscope I solder with.
Oh, so that's just a camcorder. It's not
Yeah.
anything super special.
No, this is just a 4K camcorder on a tripod.
Just a fucking camcorder on a tripod.
Right. For $800.
Excuse me.
Here, I'll take a picture of the setup. Let's see. Yep, no lube in the picture. We're good. All right. And I'm wearing pants. Good. Check.
So are you using a remote control to do the zoom and stuff?
No, I'm reaching up to it.
All right, okay. Yeah, that's better than my PVC pipe frame that I was using.
I thought that was cool. That was cheaper.
Whatever works.
Oh, it was definitely cheaper.
If it works, use it. Alright. So
Well, what I did is I just built a little frame goes up and over and then zip tied a webcam.
Yeah, it worked pretty good.
Other than the shitty camera quality.
Yeah, but
we're gonna
get a
go.
different camera if you want.
We're gonna go
Got the
off.
job done.
Gonna go off camera for a moment and show a different screen because that camera battery just died and I don't know where the charger is. So
Good times.
we'll go back to screen.
I've got a $30 Best Buy certificate, so I'm probably going to try and pick up a camera. at least a 720.
Yeah.
Just probably another webcam, just enough to make do.
Nothing wrong with a webcam. It'll do the job.
I would still look at reviews just because there's a lot of really shitty webcams out there.
Oh yeah, I know.
We'll let that continue to cool a little while. So
I should look and see what the resolution on the camcorder that I have is. I doubt it's anything.
All right, Princeton Tech. Let's look at the specs on that. So we're good. 2.2 to 3.6 volt operating range. So I'm going to need a nice 3.3 volt supply. And then, yeah, this is pretty good. So what we haven't done, and I'm not going to get into it tonight, I may do the Arduino part here real quick, but what I haven't done is the Alexa part. I kind of think that's a good break point where we split this thing in half, and we Alexa enable the digital pin once the digital, the data is doing what it's doing. So, cool. So what we need to do, and I think we've largely got the code written, is I need to do the hardware side of it. And we need to get a freaking upload going to the ESP. So where's Arduino? There's Arduino. There's the serial mess. There it is. There's one we've been working on. Come on, preferences. Where you at? We know. Preferences. It's not opening anywhere. Nice. I was just wanting to zoom in a little bit. Alright, send this one, send start bit. That's all there. So, what do I want to use for a chip? I know, how about a Wemos D1 Mini? Because there's one sitting right here. Alright.
There you go.
So actually, all I need to do is I need to run power to the micro from the Wemos. So that's 3v3. And then I got data. It's just on D1, which is somewhere. D1. Good. And then ground. So 3 pins ought to do it. Ground. Okay.
Hey guys, how's it going?
What's up?
Hey, I'm gonna keep the pirate.
We've been hacking the shit out of some stuff today, man.
So what did you find out on these? Like, how do they work? And
oh, well, I don't remember. Have you been on yet earlier? Or is this your first time joining this adventure?
I don't think he was on earlier.
I don't think he was either. All right, so we've done a lot. We started by taking apart the transmitter, the remote control for these things, and finding out that rather than having buttons that were simply digital logic we could interfere with using a microcontroller, that they were capacitive sensors. So it's like, well, shit. So rather than trying to figure out a way to, cut somebody's fingertips off and push a capacitive sensor with a microcontroller, seems a little Dexter-like, I figured we would look at the serial data stream. So what we've done is we've reverse engineered the serial protocol to not necessarily understand what all the bits mean, but know how and when they're getting set so we can create the ability to replay them. we've written Arduino code to do the replay. I just finished taking the actual IC off the board so that I could tap in a line to hook up a ESP8266, and I'm currently wiring that ESP up to things, so we'll be able to very, very soon try to upload that Arduino code and see if this thing runs. And if it turns on the switch. Yeah, so I'm thinking 10, 15 minutes, we're going to have some meaningful progress. When this baby hits 88 miles an hour, you're going to see some serious shit.
Arna, do we want to see sparks?
They didn't see sparks.
I mean, as long as it's someone else, then I'm gonna get things here. I'm good.
Babin's like, as long as they're not my sparks, I don't care.
So, Pirate, I'm guessing the IoT saying, did you remember to check this pad? Why is what it was?
Yeah,
And
so at the beginning, I thought there was just one line going to it, but it turned out to be that it split off into two. And then when I bent over the wire and I soldered the wire with the IC chip holder, it covered up the other one. So I was troubleshooting all this morning, and then I actually found it. It's like, I'm not getting a connection from here to here. And it turned out to be that one, and then I look right underneath, and it's like, oh, well, fuck me. So.
Alright, the Wemos has been plugged in. Tools. That's all set up. Let's run an upload to this thing. Let's see what the fuck happens.
So, Babs, you feeling better or worse?
I'm so much worse today. It sucks. That was
You taking something?
just getting started yesterday, I guess.
Yeah.
Are you taking something?
I went to the store and got some cold medicine, but I didn't take any of it. I had some Theraflu tea, but I don't know. I'll take something when I go to bed. I usually like taking cold medicine during the day if I can help it. I got a bunch of tea and stuff, so I'm good. Just like normal jasmine tea.
Alright, so you're getting gibberish?
Yeah, that's kind of weird. I mean, I think that's our serial stuff. D1, okay, that's why. It doesn't like the pin I'm using.
You didn't put line breaks in your serial print.
That's a print line. It'll do a line break by default. It doesn't like the pin I'm using because it's a data line. I'm going to go to a different
No, this
line.
is just pure gibberish, I think. It's like
no,
in the wrong...
D5. Hang on. This will make sense in a minute. D5.
My video dropped 360. Couldn't read it. That looks like baud rate.
Nope.
But it looks like the right baud rate to 9600.
Don't think it's baud rate. Let's see what happens now. Hey, it fucking worked! Sweet.
What did you do? I can't really see.
I was on a pin that was interfering with the serial communications.
Got it.
Son of a bitch! It worked! Alright, hang on. You gotta... Alright, I'm gonna turn it off.
We see it now.
I'm gonna turn the thing off. Alright, so my unit is off. I'm gonna...
Dude,
fuck! It works!
Wait, did it turn it on or off? Or on?
Yeah, it straight up turned it on!
That's
Your
fucking
camera's
awesome.
dead, isn't it?
Hell yeah!
Hell yeah.
Hell to the fuck to the yeah to the... Oh, that's sweet. All right, so hang on. So what I'm going to do is I'm going to get in here and we're going to add a big old delay at the end of that.
I mean, do you actually even need to do it more than once?
No.
Okay, so
hang on.
The outlets have radio frequency that you're sending it. the data, right? Instead of using the control.
So what we're doing is we're bit banging the serial data that was being created by the proprietary microcontroller that has no name or numbering, and sending it to their RF module just like it did. So we're basically doing a fucking replay attack.
Nice.
So I'm going to set this up so y'all can see it happen. Let's see if I can figure out a way to make this work, because that camera battery's like dead.
Where's the charger?
I haven't found the charger yet. I do have another battery.
Oh, God.
Wait, it didn't come with like a charger. It came with a USB cord, so it's like retarded. Alright, let's see if this battery's going to juice. Ooh, that battery does have juice. Okay. I think we're going to be able to do this. I don't. It's walking me through the setup routine. Nice. Okay. Alright. Oh yeah, we get plenty of battery power. Okay. You guys are going to lose your shit about this. This is fucking sweet. Okay, cool. So, let's zoom this fucker out and get it back on screen.
Now, you know you're going to have to write all this up and post it somewhere where other people can hack these, right?
Oh, hell yeah, we are. Hell yeah, we are.
Nice.
Okay, camera. Move it up. Alright, so, what we've got now, let's move some of this stuff and get whatever. Alright, so that's out of the way.
Oh my god, I have that exact lamp, I think.
You probably do. Alright. Let's see. So here's the unit. We're going to get it in view. It's the one right
This is
here.
the one from Costco.
The one from Costco. Here is a Wemos D1 Mini. Here is the little board that we've hacked. So let me point that shit out. The original IC.
Can you zoom in on the Wemos and the chip? Enhance.
Zoom.
Yeah.
Alright, that will maybe get us close.
So where did you? Okay.
Alright, so the Wemos is right here.
Because we never actually figured out what kind of IC that was, and we're just
Right.
ignoring it and saying, "Now we'll just send the same signal ourselves."
We're
and
made
call
of the middle unit. So yellow is VCC, blue is ground, and the green line is the data line. So I'm going to plug the D1 Mini in, and you're going to watch this thing turn itself on. It's going to be really fast, too.
And now, would you have everything plugged into? That is the controller, right?
Hang on.
It's the remote.
Oh, okay, yeah.
Let's see what happened here. It worked a minute
When he's
ago.
a second, you should show him the backside so he can see the capacitive touch buttons. So when we talk about switch 1, it's because you would be touching one
Those
of
are the
those.
capacitive touch buttons that are on the back. And then, let's see, hang on. Let's see why it didn't work. We'll make it work here.
Okay. So yeah, you just what?
He previously mapped out all the pins, and then we used the logic analyzer to get timing, and then he just took that timing.
Here we go. I'm plugging it in. And it comes on! Yay! Isn't that the shit? No, turn
That's
it
pretty
off.
cool.
Turn it on. Ding!
Nice.
And that, ladies and gentlemen, is bit banging.
That is pretty awesome.
Alright, so we just completely fucking reverse engineered an entire protocol. And made it turn the thing on. Now, I don't remember that one. That might have been on. Let's see what happens. It should just turn the one on. It shouldn't turn both of them on.
And that is how China builds cheap products.
So wait, is this doing it over Bluetooth or Wi-Fi? I wasn't paying attention to that.
It's doing it over none of the above. This is just some RF module.
Oh, and that's right.
Arbitrary RF.
We're sending it to the
Arbitrary
remote, and the remote's doing all the actual RF work for it.
Oh, that's off.
It's just blasting RF, and
yeah,
there should be a unique signal for each of the different. What is it, like a 4-pack or 8-pack?
Yeah, there is.
And they just wait for that. It's like a network card. They're only listening to packets with their MAC address for them, and then they turn on.
I wonder how you can configure that address to be a little better than.
Well,
it's probably baked in.
It's baked in. That's what we're going to have to do from the other. We're going to have to run more captures off that other chip, and for some reason it's not working right this second. So let's see what's going on.
Yeah. How many power adapters is it? Is it like 4 or 8?
It's a 4-pack, so it only turns on one, so that's good. That's exactly what we want, guys. That's been hacked. So now all we have to do is adjust the timing for the others, and we're golden. I mean, I could, if I wanted to, design another board and transplant the RF part of this on it. I'm at this point not going to do that, but that's fucking cool.
Where's the trans? I'm assuming it's just a transmitter on that board.
It is just.
That's what I was trying to figure out. I don't see it.
I'll show you. It's just modulated. It's fucking CW is what it is.
It's what?
It's Morse code. It's just bits. All right, hang on, I'll show you.
Isn't it all?
It's just ones and zeros. I understand that, but where's the transmitter circuit on
U2
that
is
board?
the transmitter. That is a PT4455 OOK or ASK transmitter. It's used for like remote key.
Which piece? That 6
that U2
pin package?
Yeah. So here's what's happening. So that line that you see that I've tapped into off of U1, coming up to that's your data inline. Coming out of U2, so U2 has this crystal, and the 2 caps on the right-hand side and the resistor, those are just for oscillator purposes to clock the chip. L1 and everything over to the left is just an LC network, probably a low-pass filter, and then the antenna wraps around the board. So coming out of that L2, on the very, very left edge of the board, going down, goes all the way down, all the way right, and all the way back up again to where you see C2 on the very right-hand side that's disconnected. That's the antenna. So it's like 315 megahertz or something. But all I'm doing is...
So that makes sense for why C2 is disconnected, because that would connect C2 to the rest of that.
Right. Well, if it was a capacitor...
Which would change the band.
It would... Yeah, probably.
Might be for different regions.
Could be.
Add that capacitor.
Exactly.
Or change values, or... I mean, it's an LC network, so you could completely redefine how that filter is working. And I'm only assuming it's a low-pass filter, because it probably is suppressing harmonics above the targeted frequency. But super, super stupid simple. I mean, there's nothing else on this board. There's this custom IC. There's a couple of support components and a battery. I mean, there's nothing to this thing. So now that that's all been done, what's left to do is to put that original IC back on the board, extract the other bit patterns, write more code, and then kind of interface this stuff together a little more permanently. And
so now what you need to do is go buy another pack and figure out how the addressing work.
Well, I can buy another pack. I can put the chip back on this one. Doesn't matter. It takes like 2 minutes.
Well, but no, because I guess it's going to be an address per outlet, isn't it? So you'll be able to figure out what part of it's the address, and we already know what part of it's the on-off.
Yeah,
there's probably some unique identifier that goes along with it, though, so that you don't go on your neighbors.
Well,
but it's probably like keys. There's probably a fixed set of those.
I bet there's not. This is made in China to the lowest fucking standard possible. I bet every one of these is freaking identical, completely. So
I guess that wouldn't surprise me.
So here's what we
now
did.
that you've reverse engineered it, just war drive, turn off everybody's lights.
So here's what we reverse engineered. So this S1
boost the power, put an amplifier on it.
So this
Oh
is
my
the
god, it'll
sequence.
be like the TV be gone, but like lamp be gone.
All right, so this is the sequence. So I'm going to show you guys. Let me get back to the screen, the right screen. Move that down. So this is the timing and sequence and everything that we did. So let me zoom out of that just a little bit. Basically, we took a capture with a protocol analyzer, and we saw a pattern. So pay attention to these. I'll make them red so they stand out a little bit better. These red triggers are the device ID things. So what we did is we compared two of them. So we grabbed them. We've got this is one switch 1. This is switch 2. And we looked at what's the difference in signaling between switch 1 and switch 2, figured out the timing, and wrote Arduino code to do that. In fact, that's all the code we wrote. And if you really want to get to the fun stuff, these are the two independent things we observed. So all of the addressing shit, or the differences were happening basically, from here back to the right. So it was just this tiny little piece. Everything to the left of that is all the same. So we literally we reverse engineered one and replayed it.
Now hang on to that, and when you do switch 2, when you do the second outlet,
Yep.
and you do the on-off for that, compare it again to this, and see if that last that last inch is the on-off part, and if maybe the part before is an identifier or a key for each outlet, and see if you can break that out.
Yep. So we've got some more experimenting to do, but hell, if that wasn't a lot. I mean, we hacked it and we turned the thing on. So that's mission accomplished.
I am impressed.
In one day. I'm impressed too because I'd never done that before. That was very much extending my skill level a step further than I've ever taken it. And using some pretty cool tools to do it. That's the first time I've ever used that logic analyzer to decode a protocol before. So with that, we're going to call this one done for now, and I'm going to shut the stream down, but we'll stay in chat. So thanks, everybody, for tuning in to this episode of Sober Boxes, because I didn't drink anything but water and soda. And before I look at that, our stream's been up 5 hours. Yeah, that was a 5-hour session. Woo!
We need to find smaller projects where they're like an hour.
Well, this was ambitious, and we knew it was going to be ambitious. And I'm like, fuck it, we're just going to do this. I literally have no need for this. I was just walking through Costco, saw that, and said, I'm going to buy that for a Drunker Boxes project.
Once you mentioned that, I went to Walmart and I was looking around to see if there's any cheaper ones we can break open too.
Yeah, I mean, getting this working and having a quick, here's the code you need, here's the mods you make, people will pick this shit up and go crazy on it. And it's going to become a thing now that someone's done the legwork. So there's still more legwork to do, but very cool. Very, very cool. All right, the stream is stopping. Thanks, guys.
Awesome.
See you in the next Drunker Boxes.